His isn't on.
Mine's not on.
There
Now
it
it is?
We're good. Microphone check. One,
You
two,
guys
one,
hear
two.
me in the crowd? Yeah? Good? Okay. We're going to get going in like 30 seconds to a minute. We're almost there. Almost there.
We're good.
All right, we ready?
Yep.
Should we get moving? Okay, we're going to get moving. Thank you everyone for coming this morning. We appreciate you being here. We're really excited to have this session to talk to you about the power of hands-on training in your programs. We're going to do a lot of things today. We're going to talk a little bit about, actually I'll talk a fair amount at the beginning here. My name is Mark Mangelson. I'm the Chief Revenue Officer at Skillable. This is Corey Gibson. He's our head of solutions engineering and all of our pre-sales technical work at Skillable. So we're sort of joint co-presenting today. We're going to start a little bit. I'm not going to talk a ton about our company. That's not what we're here to do. I really want to try to sell you more or less on the power of just hands-on in general and how you employ that in your training programs, how you think about it from an upskilling perspective, how you think about it from a partner enablement, customer enablement, your engineers, your technicians, all digital skills within your organization. So that is really our purpose today, and we hope to make you believers at the end of this if you're not already. So, just a little bit of housekeeping. As we get in here, this is where you can access and join the discussion. If you have any questions for us, I should say, throughout the presentation or at the end, please feel free to go to the app, submit it here. We'll see it later, I'm not sure when, but we'll get to it. We'll respond to you, I promise. Also, after this, just grab us and we can answer any questions if you have any as we go forward. Okay, let's get into it. So, again, this is really the 30 seconds of who we are, just in case you're wondering why we are here. Corey's going to talk a little bit about how we're partnered with Cisco to deliver some of their hands-on experiences for the CCIE capstone, but more on that later. For now, we are the largest hands-on training organization in the world, really, in the market. And we have 254 plus customers today. That list continues to grow kind of weekly, monthly, quarterly. We've delivered over 50 million labs, hands-on training labs throughout our history. We have the highest customer NPS of anyone in our market. So in other words, people really love to work with us. That's great. That's not what we're here to tell you about. We obviously work with a lot of great customers and companies. I'm sure maybe some of you work for a few of these companies or know them well. That's all good. On with the show. Okay, so why hands-on? Why do we talk about this? Why is it so important in your programs? If you think about this, we spend so much money. $10,000 on average is spent to develop 1 hour of really good training content. Whether that's video-based, whether it's PowerPoint, it doesn't really matter. It's kind of the average cost to spend to build a really effective hour of training content. What's crazy about that, as we know, is that the knowledge that you actually retain and that you acquire throughout that training content, whether it's video-based, on average learners use only about 12% of that knowledge. 70% of that knowledge will be forgotten within 24 hours if it's not properly applied. So in other words, we don't take that knowledge coming out of any sort of training, whether it's a classroom-based thing, whether it's web-based, we forget it. And we don't apply it, or if we don't apply it, we forget it rather. So, it's not though because we don't have a lack of options, and there's not because there's not good tools and content out there. This slide is intended to be overwhelming and just obnoxious because it's illustrative of all of the different tools and capabilities that exist in the market. There's lots and lots and lots, whether it's technical training, upskilling, whether it's practice environments, coding environments, doesn't matter, leadership development, whatever role you might be in, there's so many different options out there. So it's not because we don't have lots of companies trying to solve this problem. It's just the reality of how we think about knowledge and how we think about application. So, our premise or thesis really in the market is the value of hands-on inside of that equation. And we're going to talk about that a little bit. Think about the value of hands-on environments for your technical folks or for your customers, partners, engineers. Doesn't really matter. Being able to get into live environments, applying that feedback. You learn something and now I go into a lab or I go into a live environment to apply what I just learned or to practice what I just learned. And then lastly, the idea of boosting retention. The inverse of that stat that I shared on the previous slide, which is 70% of knowledge gets forgotten, the inverse of that slide is that when you do it, when you actually do application, right, after the fact, after the learning, 70% of that that knowledge is actually retained. And so that is our premise. That's basically our mark on the industry, is to use more hands-on in your training and training programs. I want everyone to just think about this for a minute. Think about yourself, and think about your partners, maybe customers, your colleagues inside of your organization, and think about the training experiences that we go through. Everything from skills that we might try to acquire, the data around that. We'll go through instructor-led training situations. You might go through simulations. You might go through different video-based courses. All of that is great. We are not here to tell you that it's wrong. We are here to just say that it's not everything. It's sort of incomplete is the picture. We love all these things. We love the fact that we do training in classroom, web-based, etc. It's just a hands-on portion. So think of hands-on being this idea where we can go and learn. We can learn in a hands-on environment, in a live environment. We can practice, put people into sandboxes, give them access to these live environments that they work in every single day. These real-world environments that are contextualized to their jobs, and then the ability to validate that they actually know this. Do you have the skill to do the job? So many organizations today are leaning more into this idea. Before we actually put you on the job, we need to know that you know this. Not just that you've completed the course, not that you went through onboarding. Do you actually have the skill to be applied on the job? We need to know that before we turn you loose into our environments. Technical skills today are the most organic skills in the economy. They change all the time. AI is making that even worse. But even before AI became AI, it actually was the truth. The most organically changing and fast changing skills are technical skills. How do we stay ahead of that today? The answer is live environments. Now, fun exercise that I just love to do with people. I just want you all to think about this today. Think of something that you learned to do recently outside of work. Just think of something you learned to do recently outside of work. Could be that maybe you took a class on, I don't know, cooking. Maybe you did something else. You created, a new hobby. Maybe you learned to play pickleball. Maybe you learned to do, I don't know, whatever it is. How did you learn it? Does anyone want to share? I mean, you don't have to, but does anyone want to share anything you learned? What? Okay, so you learned right over here. You've got that. Okay, great. Any other examples? Anything else? That's a great example, by the way. I'll just use it right now. How would you demonstrate that you could do that? You just learned it. How would you demonstrate it? Okay, got it. So the answer, I mean, I hear you as a general rule, and the answer is kind of universal anyway. The only way you would demonstrate that you can learn it is not by telling people. You'd have to show somebody. You'd have to actually go into the live environment. You'd have to show somebody that you know that you can do that, right? This is how we think we learn. How we think we learn is in classrooms and in these environments where we sit down, or in a self-paced way. That's how we think we learn. It's not how we actually learn. The truth is not how we actually learn. Knowledge acquisition is very important to the learning process. How we actually learn is we take what we've learned through a video or a course or whatever, and now we go apply it. Imagine if I came to you and I said, hey, I watched this video on how to make the most amazing risotto. I'm an expert. I know how to do it. You guys would be like crazy. And I'm like, I'm just gonna make it for you. You're gonna love it. It's awesome. I'm an expert. Not true. Doesn't work, right? You have to actually get your hands dirty. You have to actually engage in the process. That is our premise today. Learn by doing, not by viewing. More hands-on, more application in your training environments and in your real-world environments. So we're going to talk about this today. I won't spend a lot of time on this, but the idea is these live environments. This is an image of a lab that we have created for Cisco. It's basically a CML environment here. On the left, you have the live environment that somebody would work in. It's not a simulation. It's literally a live environment that somebody might work in. On the right is the instructions that the actual live environment wraps around. And so the ability is, or the real benefit is for people anywhere to be able to access these real world environments with an instructor present or not present, real world technology, again, with live up-to-date information, again, not a sim that's been captured or copied, actual live environment with purpose-built scenarios designed for you, designed for your role, designed for the purpose of what you actually are trying to learn, the job that you are trying to do, the skills that you have to have inside of your job, contextualized for you. So, this is where I end and I pass it over to Corey. The idea is leveling up your effectiveness of training initiatives. So many benefits to doing this. These are just a few. Again, we're Skillable, but don't take it from us. Whether you use us, whether you use somebody else, whether you try to do this on your own, we're just big fans of you doing it. And so we really don't care. If you want to talk to us, that's awesome, but the benefits to having more hands-on in your environments are immense. Building real-world expertise, improving job readiness and tech, boosting learning and retention, efficiently managing sandboxes, deliver effective training and in-demand technologies. The list goes on and on. The benefits of hands-on, immersive experiences for your training, for your learning, is just, you cannot understate it. So that's our pitch to you today, is to take advantage of more of these things, invest in more hands-on in your training today, and you will not be sorry that you did it, I promise you. So with that, I'm going to actually let Corey, colleague, take us into an actual live environment. He's going to walk you through what it looks like when you actually do this in the real world. So Corey, hand it over to you, buddy.
All right. I need just a moment of interaction. How many folks are like knock leads or some kind of IT tech lead or something like that? Or you work close with your lead? Anybody? Okay, cool. So when most of you go, or how many people have been through college or some sort of certification training course? Probably everybody, right? Like, we're a great plug-in to that. So think of like the as a service stack, right? You have software as a service, infrastructure as a service. So most training is software as a service. You log into a portal, you get some canned stuff. That's great. That's been curated. Like, we know this stuff works. Where we start to come in is those gaps that you start to feel like, this was great, but it doesn't, my organization does it this way. Or I need to know it this way because it's a little bit different. Or, man, I need an Azure piece in there because my organization does networking, but then we back everything up to the cloud or something like that. Where Skillable comes in is we can help fill that gap, because we are a platform built for hands-on lab building. So rather than just getting pre-canned stuff, you can ask us to build you stuff and we'll build it for you, deploy it to your organization, but you can also get access to the platform. So where Mark used his cooking or learning how to cook, you know, if you look at restaurants would be like the SaaS of meals, and where it's just delivered to you. It's kind of like how the training is today. And if you want to go out to Azure or something like that, or get your own on-prem stuff that's more like your infrastructure as a service, you got to know what ingredients you need. We fill that gap in sort of the platform as a service, infrastructure as a service method, where we're the meal kit to that stuff. We know what everybody needs for training, but we also know that people need to customize it in specific ways for their needs. So I'm going to run you through a couple of different scenarios in one lab. So I've built one lab that's going to serve many different needs, which means if you're deploying this to your organization, you don't have to manage a billion different scenarios. You can build one environment and make your content the star again. So, you know, environment building is one thing. You need certain skills for that. Content building is another thing. You end up spending a lot of money on that, and that's really the thing that's teaching people. And I'm going to date myself a little bit. My background started as information security. So I went through an information security degree, and I just remember at the beginning of my semester, the first 3 weeks was taken up with building your server farms and all that stuff. By the time you were done with that, the book became a second. The thing that's actually going to give you the knowledge became a second. What Skillable's done is they've let that thing be the star of the show again. So it's no longer everybody's focused on the environment. You got to make sure it's right. You got to make sure it's built. We can get that stuff deployed into students' hands at the click of a button, because it's all web-based. All you need is a Chromebook and an internet access, so you can run a browser. So we always say, you just need a device that can support a browser and have an internet connection. Let our data centers handle the rest. By the way, we've got global data centers. We're partnered with Equinix, so we have data centers all around the world. So your folks in APAC, EMEA, North America, they can get a solid connection to something close to them, so they're not having to deal with latency as well. Okay, so on the left-hand side, did I change that properly? Let's go. All right, let's do this the hard way.
Got to get your screen share up.
The demo gods are not appeased today. Let's do this. You go away. There we go. You know, if you just kill a whole program, it'll stop showing it on the screen. All right. So this is the actual demo lab. On the left is always going to be your environments, the thing you need, whether it's Azure, whether it's something on-prem, or it's a mix of the two, it's a SaaS platform. All of that can be displayed on the left. We can empower that. If you notice up there, I've got a Ubuntu machine. I've got CML running. This is the lab that we partnered with Cisco. And has anybody heard of NIL before? NIL's a training company in South Africa. They've got this beautiful initiative called the 525 program. It's to certify 500 CCIEs by the end of 2025, and they needed a way to help. For those of you who have taken the CCIE or you're studying for the CCIE like myself, it's an incredible task. So what they needed to do is not reduce the standard of the exam to pass, but try to increase the pass rate. So what we did, we partnered with them to create a capstone. I am not going to run you through a CCIE capstone. I made a condensed version, more like a CCNA level, so that it's easy to kind of do and walk through. And screensaver, demo gods are on my side today. So what you'll notice here is left there, right is the instructions, but it's not just content. What we can do is we can embed, let me go over to the next slide. We can not just embed content, we can also, on demand, change scenarios to whatever you'd like it to be. You can automate what I just did, that click of a button. You can automate that, like assessment comes up, and all of a sudden they get the scenario that fits their skill level. And then at the bottom, there's some interaction. You're gonna see these little buttons here. Those can like type directly into the console for them, so you don't have to worry about passwords tripping you up. But the real power is, and I've done a little bit of work before this, so you don't have to watch me go through configuring a router and a switch and all that stuff, because who wants to watch that? But what's happening here is it's actually running. We're using the PyATS library to see if I've configured this OSPF neighbor right. Not only is that giving me, the user, some interaction on demand so I can see if I'm doing stuff right live in the moment, but it's also creating a data point for your organization that you can pull back to either see how your training is affecting other people, or you can port that out to leaderboards to gamify the situation. So you can use your own leaderboard. You can port all this data out to that leaderboard, your own data lake, so you can model that data so you can see how your training is working. So what you just saw there is just a simple learning how to do stuff. For the NOC leaders, the next thing I think you're gonna like even more is when I go down to this chaos environment, I'm gonna click this button. This is gonna reach out to an external service I have that's got a few different scenarios for this topology. It's gonna break it in a random way, and then it's gonna pull in the scenario that matches the way that broke. So when I click this button, you're gonna see the instructions change. So for me, it's reaching out to GitHub using a GitHub app, and I've got a functions file, and it's randomizing through what function it grabs, and then it knows from the function I need to give this specific scenario. So think of your NOC teams, think of the tickets that you get. You can now make a support request. Now you can turn that into here's how you actually do that. Instead of an agent having to sit on a phone or in a ticket and type back and forth, you can deploy them into a lab that has that exact scenario that probably matches their infrastructure, their needs, and they can learn how to do this stuff and fix it themselves. Or for your NOC folks, when you take your top 5 most trouble tickets that have the most difficulty for your team, you can create that scenario here, and then you can start giving them feedback on how they're doing and how to deploy it, how to fix it. You can gamify it, like, hey, who's gonna fix this thing the fastest? So if I scroll down here, I'm not gonna do anything here, so you can tell that it's actually gonna give me some feedback here. So I have not fixed, this is a Flappy port that's like basically turning off OSPF every once in a while on me. What this is doing is it's just saying, hey man, you didn't do this right. So if I go in, I configure the router and I do it right again, then it'll then tell me that I did it right again. And so you've got this sort of interaction between your content that you're reading, so you're not just on this PDF on the right or on another screen somewhere, and then you gotta go find your environment. You can split these screens apart that you see here, so if you do have dual monitors, don't worry about real estate. We have saved you on that one. I'll stop there. Are there any times that you've been through your training and you've kind of been like, where are my credentials? Where's my PDF? Where are my instructions at? I'm over here in my environment. Yeah. What Skillable is great about is this thing called that we call orchestration. So whether you've got an environment that's on-prem, whether you've got cloud resources, whether you've got both, we put all that stuff together. We can create variables and instructions to pull in credentials live from like SaaS environments, cloud environments. I've talked a little bit about cloud. One thing that we didn't put in here intentionally, but I'd like you to come down to our booth 1741 if you've got more questions about this. We developed essentially an entire technology called Cloud Slice, where you can take a cloud subscription and you can slice that up, you can policy around the user, you can deploy resources. It'll come behind and clean up, just like it will do in these environments that you see on the left there. All that stuff is on demand. It doesn't exist when you click the button. It exists after you click the button. When you're done, tears everything down for you, so you're not paying for like orphaned resources out there. Has anybody used training in the cloud, like set up big AWS infrastructure for your training folks, stuff like that? Yeah. So we can tear all that. We have native integrations with AWS and Azure, and we can tear all that stuff down for you. We can even deploy your cloud formation at the click of a button, get all that stuff up. I've built stuff for customers where like, hey, they needed a full Nutanix cluster running. That had to be connected to an AWS infrastructure replica so that they could back up and create some redundancy. And that was all done at the click of a button in under 2.5 minutes. So pretty awesome. And then at the end of the lab, it tears all those expensive resources down, because we had like, if any of you have used AWS, we had to use bare metal. Bare metal's super expensive. It's not super expensive if you can condense it into these little 1-hour bits. Then you're not paying for whole days or weeks of something running. You're only paying for just an hour or 10 minutes or 30 minutes or however long you want those people to use that resource. I think the power of our platform comes there. Like, not only do you get the real experience, it's not some sort of simulated walkthrough or a very locked down environment, but that we can also do this stuff on demand. In a few minutes here, I'm gonna stop so that we can take some questions, if that's okay. And then if you need more information, come down to our booth again at 1741. I got that right, Jade?
Corey, can you guys hear me okay? Still? Okay, I'm still coming through. Okay, great. Just one very quick point that I wanted to mention here while you're transitioning. Again, you know, we're Skillable, but we just want you to do it no matter what. We want you to sort of think about this more in your training programs, your certification programs, whatever. There's 3 main applications that we always like to talk about hands-on being relevant for inside of your organization today. And again, you can think about it through the lens of your customers, your partners, your employees, all of those. First one is learning. So think about these hands-on environments for the sake of learning. You're just trying to train something, train somebody on something. Practice. In other words, I just need to give somebody a live environment they can go practice in, play around. I went through a video, went through a course, I went through an instructor-led session, doesn't matter. Now I want to go practice. So very, very sort of low consequence, low fidelity. The last one is certification. Think about certifying individuals. I have to know you know something. I'm literally going to hand you a certification. And the way to do that, the only way truly to do that, is to actually make sure that they know how through a live, real environment. An environment that you can't go into production and break something because you just can't put people in it. An actual live environment that has the scenarios, says, hey, go prove that you can do this thing. So if you take that away today, that would be helpful for me, just to understand and remember that it's really learning, practice, validation. Those are the 3 main applications as you kind of get your minds thinking about how do I go back to my organization and really start to empower our users, my colleagues, our teams to use hands-on in their real world. It's really through the lens of those three ideas. Go ahead, Corey, you can finish this out.
Yeah, for the nerds in the crowd, I just want to point out that's RDP showing a VNC connection through an RDP connection. I just want to, for any of you that have done something like that and made it smooth. So we have about 28 seconds, and then we'll move to questions. I wouldn't be doing my due diligence as an SE if I didn't start using the AI buzzword. So not only can we also empower you to teach your folks how to build like AI ML kind of workloads, so you can also build LLMs yourself in local environments. We also can add that to the instructions. I don't know if anybody saw the Padres game, but if your learners are in here, everybody talks about embedding AI to make these kind of real experiences. So if I wanted the Padres score, we can allow you to point this AI to your LLMs. You can bound it into what the lab's about, and it's very, very nicely says, we need to keep our discussion focused on OSPF, and then it starts giving me some OSPF questions. So what's really awesome is just gating the experience. So if you think about sandboxes, right, the difficulty I always came up with is it didn't feel like a sandbox I was being dropped into. It felt like a desert. Like someone was just dropping me in the middle of a desert. But if you think of a traditional sandbox, it's got a boundary. It's got something in there for you to kind of focus on. And then it's got some room to play. That's what Skillable does really well. It gives you the boundaries and it can point you into the ways. So when you think of enablement, so the verticals to think about here aren't just your NOC teams. Think about enablement. Think about onboarding. Think about SEs. I demo with this every day. I use POCs. I learn my engagements when I'm going through onboarding and POCs based on where people are going. So when I'm doing my check-ins, I can see that data and I can say, hey, our success metrics were this, this, and this. Looks like we're doing pretty good here. How do you feel we're doing where I know that they're getting tripped up? And you can help facilitate those conversations. So for teachers, it helps your open hours be more focused. For onboarding folks, it helps your onboarding be more focused. For NOC folks, you can go to your folks that are having difficulty with different things and you can say, hey, how you feeling about this technology, this thing that we have to do? And you can open up that conversation knowing where the problems are. So I'll stop there. We've got 3 minutes. I told you I would take 20 seconds, but in true sales fashion, I took an extra 120. Are there any questions, any ways that you guys would see this deployed in your organizations that you could, that we could help you with? Or anything that you think that we could look toward? That's a great question. So he asked, we're using CML. CML is a licensed product. It's got a free tier that allows 5 nodes. He asked, if we ever need more than 5 nodes, do we need a license? Yes, because CML requires a license. What we're really good at, remember that orchestration portion? This is what puts us in that sort of powerful platform as a service, infrastructure as a service in the learning environment. When we launched this for Cisco themselves, we automate the registration and deregistration through an enterprise license. We've done this with colleges, with Personal Plus licenses, so that you can take your licenses, give them to us. We can automate the deployment so that you don't have to buy like a billion licenses. You can buy the ones that you need for your students. You can register and deregister those devices as they come online. And then also, again, this is all in the cloud for you guys. It's on our data centers. So there's no requirement to keep this sort of big infrastructure locally. You can let us handle that burden for you. That was a great question. Thank you. We have about 1 minute and 46 seconds. For the WebEx folks that might be joining us, I'll get to your questions after this, I promise. I just need to get through this session, and then I'll answer your questions. Please let us know. Again, if you are walking around, we're downstairs at the booth. We've got a Pac-Man machine, by the way. If you get the high score, there's a prize. So come down and see us, please. And then also, please reach out to us afterwards if you want to talk more about this. I can also show you how building this stuff works. It's pretty easy. It's not like the Azure environment or your public cloud environments where it's difficult. We've taken all those hurdles and boundaries obstacles out of it for the lab builder. All right, thank you very much. This has been great. We appreciate your attendance.
Thank you. Appreciate it.
Hi, good morning everybody. My name is Rich Bibby and I'm a product manager with NetBox Labs based in the UK, so really pleased to be out here in San Diego to deliver this session. Thank you for coming this morning. I hope we don't have too many sore heads from last night's celebration. Yeah, okay, so let's get into it. If you want to, follow along. There we go. Sorry, you can ask questions in the Cisco WebEx app after the session. So please do that. If you have any questions, we'll hopefully have some time at the end for some questions as well. Okay, so let's run through the agenda. I'm going to introduce NetBox and also NetBox Labs for those of you that aren't familiar. Then we'll talk about event-driven architectures, and we'll dig into what we mean by that exactly. And then we'll get into a demo. The demo I've recorded, so we'll go through that. It's about 15 minutes long, and we'll see all sorts of technologies in play, Ansible and NetBox working really well together. And then hopefully we'll have some Q&A time at the end. Okay, so introducing NetBox and NetBox Labs for those of you that aren't familiar. Just quick questions. Anybody here use NetBox? Put your hands up. Fantastic. As we know, NetBox is very popular. It's used in networks of all shapes and sizes all over the world. NetBox Labs, we are the commercial stewards of the NetBox open source project. So we were founded in 2023 in New York, and we like to think about this virtuous circle that we have. So we reinvest from the money we make from the commercial offerings of NetBox, we reinvest that back into the open source NetBox project. NetBox itself is an insanely popular project on GitHub. If you look at the number of stars, the number of software commits, the number of contributors that want to contribute code to the NetBox project is really huge. So what is a network source of truth? So it defines the intended state of the network, and this is the key thing. It's your intent. It's not what's actually out in the network, but it's your intent. So, and it represents it as structured data. Now, by representing it as structured data, that means that other tools like Ansible, for example, can interact with NetBox in a programmatic way and work with that data. It should be a single, consistent data set as well. Sometimes we find that adopting a network source of truth requires a bit of a mental shift for network engineers coming from traditional ways of working with documenting networks. But ultimately, the source of truth becomes the authoritative reference then for your network, and the data within it can be used to then drive network automation. NetBox is the world's most popular network source of truth. Really comprehensive data model from ASNs through to VPNs and everything in between, built with an API and integration first approach, so it's really great for other systems to be able to connect with NetBox. Hugely extensible. You probably know there are things like plugins, device types, custom scripts, custom fields, all sorts of extensibility. And there's a huge ecosystem of other products that work with NetBox as well. Now at NetBox Labs, we see people coming to us at various different stages of this journey towards 3 here, which is when we're really getting into network automation. But a lot of people start out really at stage 1, which is where they want to get rid of all those legacy sources of network information like spreadsheets with IPAM data, cabling, that kind of thing, where your racks are, that kind of stuff, which, as we all know, quickly becomes out of date. It's inaccurate. Dave left the company 3 months ago with half the stuff. Nobody knows where this network information should be. With NetBox, then you just consolidate all that network data into a single location in NetBox. And then you start to change your operational processes as well. So we actually start to make changes in NetBox rather than the network devices themselves. When we get to stage 2 then, we've got all our data in, and we then really link the two main models of data in network, in NetBox, which is the DSIM data and the IPAM data. And one of the really great things is you can then start to enforce consistency, things like naming conventions, which are so important for devices. You can start to be consistent with that. And what you end up with then is a platform that you can really drive network automation from, because you have an accurate source of data to work with. So I'll just run through this one very quickly. You're probably familiar. There are a few different flavors of NetBox, really. There's the Community Edition. We have NetBox Enterprise and NetBox Cloud also from NetBox Labs. So with Enterprise, it's still self-managed. It runs on your own infrastructure, but we support it. You get access to a ton of advanced features. that you don't get with NetBox Community. And the same with NetBox Cloud, but Cloud is basically the SaaS offering of NetBox platform. So with that, you just consume it as a service and don't worry about maintaining any of it, backing up the database, plug-in compatibility, all those kind of things go away. Okay, so event-driven architectures then. Let's just have a quick look at this diagram. So what we're talking about here, we've got NetBox in the center here as the source of truth, defining the intended state of our network. And then if we look at some of the areas around NetBox here, if we look at we've got the network itself up in the top right corner, that's your devices, maybe there's some controllers in there that are managing the network for us as well. And NetBox, we remember, is documenting the intended state of our network. Now, what we want to look out for is when there's a difference or a delta between our intended state as defined in NetBox versus what's actually out there. And that's where tools like your monitoring tools, your discovery tools, and also NetBox Discovery, which I'll show you in the demo, work alongside NetBox Assurance to show you when there's a difference between your intent and what's actually out there. But then ultimately what we've got here, the demo we're going to see today, Ansible is going to talk to NetBox to get its dynamic inventory data and also the data it needs to run playbooks to configure our devices as per our intent. Okay, there is an Ansible certified collection for NetBox. We got it certified about this time last year, so that means that NetBox Labs customers and Red Hat customers get official support on the NetBox collection for Ansible. So the certified collection is available from the Ansible Automation Hub. Now, there are modules in there that are used to define the intended state, so that's making updates to NetBox. You can use the collection for that. But there are also plugins that we can make use of as well to drive network automation using that data that we have in NetBox. There are a ton of use cases we have as well now with the certified collection. So the first one really is NetBox as a dynamic inventory source for Ansible. So if you're familiar with Ansible, you might be using YAML files to find your inventory. You don't need to do that anymore. You just point Ansible at NetBox and it gets its dynamic inventory data from there too. We can define the intended state in NetBox. We can query and get data out of NetBox using the collection. And we can also do things like event-driven Ansible, which is the point of this. So we can fire webhooks, for example, from NetBox to event-driven Ansible to then configure our network. Okay, this opens up a bunch of possibilities. So we can start to think about automating some of the common tasks that we see. So just a few examples here, things like you want to update your NTP servers across a bunch of devices, login banner updates, anything you can think of really, provisioning a new VLAN, fully through to sort of deploying a new device and pushing out a full config to a device as well. The list goes on. Now, so what we're going to get into here is how this actually all hangs together. So we're going to make use of something called event rules in NetBox. Now, event rules are there to automate actions based on specific triggers. So the actions that you can do could be to run a custom script, could be to send a webhook, or to generate user notifications inside the NetBox UI. And they're conditional as well, so they can include a set of conditional logic. Just an example here is that we have an attribute of status and the value must be active. So you can be very granular in your approach to what will trigger a NetBox event. We then, in this case, we're going to use webhooks as well. So webhooks will respond to an internal object change or that event that we just talked about. Then the receiver, which in our example is Ansible, event-driven Ansible, can then take action on the data that it receives in that webhook. It supports Ginger 2 templates, context data is available as well, things like the event, timestamp, the username, all of that data is available for us in the webhooks. Okay, and here's just a quick example. So this would send a message to Slack anytime an IP address object was created in NetBox. So we've got the object type is IPAM and IP address. The HTTP method is a post to the receiving system. The URL will be the Slack incoming webhook URL. Content type, and then there's the body. And you notice the variables here that we're making use of. This is data that's being pulled out of NetBox to populate that. Okay, so we'll get into the demo. And I've recorded this because I'm not very good at speaking and typing at the same time, so I thought it'd be easy to record it. So let me just get this to play. Yep. Off we go. Okay, so in NetBox, if you're not familiar, we're looking at the organization here. We have a site, obviously, called San Diego. And within this site, we don't have too much at the minute. We have a single device, which is a CSR 1000V. And if we just drill down slightly, you can just see the kind of, the kind of data that you can model for devices in NetBox. So what we have here is, you can see the platform, it's a WAN router, it's active, we've got the serial number, and we also have the interfaces, so you can see the status of these interfaces, IP addresses, MAC addresses, and so on. Okay, now to build up our device configurations and use some of that data in NetBox, what we're going to look at is config context. These are really powerful. So we've got a bunch configured here. The first one I'll show you is San Diego NTP servers. So we have some JSON data here, which is defining a couple of NTP servers. But the key thing is we're actually assigning it to the site level of San Diego. Now you can be very flexible there. Obviously you can see you can assign config context to various different object types within the NetBox database. But what we're saying here is that anything in the San Diego site is going to have these syslog servers, is going to have these NTP servers, is going to have the domain name, and I think the name servers as well are what we have configured for those. So the way this plays out in NetBox is if we now go to the config context tab of our device, all this has been pulled through from those different configuration context snippets that we saw that JSON data. So we can see we've got the domain name, the name servers, NTP servers, and syslog servers. So any devices in San Diego are going to pick up that configuration context. Now, this is where it gets really powerful. We combine this now with the event rules. This is what we're talking about. So we're looking for an event to be triggered to send something. So our event rule here is called Ansible EDA on branch merge. And what we're doing here essentially is we're sending a webhook to Ansible EDA, and we're sending it when the job is completed. So we're talking about a branch here in NetBox, which means, well, I'll show you that in the demo in a second, but we're going to create a new branch of the NetBox database, work in that branch, and then when we merge the branch and that job is completed, we then fire the webhook. So you can see, here's it's very simple configuration. We're sending the post request, there's the URL, content type is application JSON. We're leaving the body template actually blank because what we're going to do is filter the incoming data based on what comes through in the default setting. So here's some code. This is the Ansible side of things. So very simple playbook if you're familiar with Ansible, but the key thing at the top here is we're actually going to extract the data for the NTP servers from the host variables for this device. And then we're going to apply that data just using the Ansible Cisco iOS module for Ansible. Don't worry too much about this at this point, but basically it's getting the data from NetBox. So that was going to do NTP. This is a bigger playbook that we'll see running in a second as well, which actually has a few different roles. It's going to apply the NTP settings, syslog server, name servers, and the domain name settings. And we'll make use of this playbook when we add a new device into NetBox, because we want to push out some of the standard configuration that we've got in those config contexts. So I mentioned one of the key things of the Ansible collection is the inventory, the dynamic inventory. So if I run the Ansible inventory command here, and this will connect to NetBox over the API, pull back that structured data that we talked about, and we can see we've got obviously the CSR device, that's the only device we've got in there. We can see all the details about the device itself, but the key thing here we're looking for is the config context data that's also been pulled through. So you can see it's really powerful when you work with the dynamic inventory in Ansible. You can make use of lots of this data that we can get from NetBox. So now I mentioned a webhook. So Ansible EDA is listening for a webhook coming from NetBox. So this is the code for the webhook, and there's a GitHub repository I'll send you details, or you'll see details of in a second. But what we're looking for is this job ended in the model branch and some text containing the words NTP servers updated. And this bottom one here is when a new device has been added. So the payload is going to contain the word branch, and also we're going to search for the word creating device. It cuts off slightly there. But you can see that. So what I'll do now is I'll kick off the actual EDA side of things. So we'll just run a command to basically run this rule book that is now listening for NetBox webhooks. Here's our command. Now, we've fired up the Ansible EDA side of things, so it's sitting there waiting for a webhook to come from NetBox. So what we'll do now is we'll do something, we'll create an event to actually trigger that webhook. Just to show you, we're working with obviously a real device here. If I just check the NTP servers that we've got configured at the minute, you can see we've got a couple in there. They reflect what's already been configured in NetBox. So now what we'll do next is I'll create a branch. So we're creating a new branch of the NetBox database. We'll call it NTP updates, just so we know what it's referring to. And we'll click create. You see it goes through the provisioning process. And if I just refresh the screen there, you'll see, bang, it's ready now. So we have a new branch to work with. And what we'll do, I think, is activate that branch. So I click on activate, and you notice at the top we're working in the NTP updates branch now. This means we're not working in the main NetBox database, we're working in a branch of it. So you can think of it as being like Git-like in its approach to branching and then merging and so on. So what we want to do next is actually make a change to our NTP servers. So we're going to add a new one into San Diego. So we'll just do a quick copy paste here, change the last number to 12. So we've added a new NTP server into the config context for San Diego. We'll click save. No webhooks have been fired yet because we've not triggered that event yet. Remember, the event is going to be triggered when we merge the branch. A really powerful feature of NetBox actually is branching. So we can see now there's a difference between the main NetBox database and this branch that we're working in. And the difference you can see currently, the green data there is the NTP servers. So we're one change ahead now. So you can see afterwards we've got 3 NTP servers instead of the 2 that were originally configured. Now, we're ready to merge this because we've reviewed the data. We're happy with the changes we're going to make. So I'm going to click merge, tick the box to commit the changes, and then we'll merge the branch in. Okay. Now remember, branch merge was the event we were looking for. So here we go now. We switch over to event-driven Ansible. The playbook, well, the webhook has been received. The playbook is now running. It's getting the data out of NetBox, and it's applying the new NTP configuration to our CSR1 router. So if I go back here, just so you believe me, we've now got the additional NTP server that's been configured. So really simple, really powerful. Hopefully you can start to see some of the possibilities here with this kind of combination of tools, NetBox and Ansible. So we'll take it a little bit of a step further now. I think when the demo catches up, when I catch up with the demo. Here we go. Okay. We're going to use something called NetBox Discovery now, which is pretty new. This is available in the community edition of NetBox as well, but we're going to discover a subnet here. So this is our configuration file. Our target subnet is the 172.24.00/24 subnet. And what we're going to do with NetBox Network Discovery is check all the IP addresses in that subnet, scan them for IP addresses that are up. We can check for certain port numbers being up. So I'll kick this off. These run as agents in your network. So we'll kick off the network discovery. It's a Docker command. You can see it's scanning that subnet now, and it's looking for the IP addresses that are up. And we'll quickly switch now to NetBox Assurance in a second. So we've scanned that subnet. So there'll be some new data now in NetBox that wasn't in NetBox previously. So what we're looking for, if you remember in this in the automation overview, what we're looking for is deltas or differences between the intended state versus the actual state. So now we've just quit that. If I go to NetBox Assurance, which is a plugin available in the commercial editions of NetBox, we can look at the active deviations, and we can look at the deviation types. So what we can see here is we've got a bunch of different deviation types. And if we look at I think we'll see one in a second, which is discovered new IP. So if we go to active deviations, we have a new IP address, which is actually a new router that we're going to apply a configuration to shortly. So you can see new IP address discovered by NetBox, the changes that would be written to the NetBox database. If I click on the changes tab, you can see the new data. So this is where, this is the difference between what's currently there and something that we've discovered and ingested, or we will ingest into NetBox. Okay, it's picked up a description on that IP address as well. Now, I'm going to apply this because we've reviewed it, and I'm going to apply it straight into the main NetBox database. But because we've got a new IP address now, we can add this to the the device discovery functionality that we have with NetBox now as well. So we're opening up another configuration file here for our device discovery agent. I'm going to uncomment this section down here, which if you remember is the new IP address that we've discovered. We're going to pass in some variables for the username and password, which we can pass in as environment variables here to the Docker container when it runs. So we'll just uncomment this. And there we go. So we'll save that file, and then I'll run this as a device discovery agent as well. Again, this is all available in the community edition of NetBox. So what we're going to do now is we're going to connect to this device using NetBox device discovery, and we'll see what data we can retrieve. Under the hood, NetBox device discovery uses Napalm, which obviously you're probably familiar with. There's a Python library. It's a kind of an abstraction layer, really, that allows you to be concentrate on the higher level things that you're doing instead of worrying about the actual device drivers that we're talking about at the lower level. Okay, so we are running this this device discovery at the minute. I think that, yep, that's executed successfully. So now if we go back to NetBox Assurance and have a look at our deviations, we can see we have a bunch of them here, all relating to this new device called CSR2 that we've discovered on the network. If we have a look at another one, have a look at actually one of these deviations, I think we click on, we'll look at the device first. This is all the data that's been pulled back about this device using Napalm with NetBox Discovery. And you can see it's obviously Cisco, it's another CSR 1000V, 1000V, WAN router, we have the serial number, it's obviously in San Diego. If we check one of the interfaces as well, we can see really detailed information that we've pulled back using device discovery. Right down to the level of things like the MAC address, the MTU size, the status, is it enabled, the speed, and the description and so on. So this is just the example for Gigabit Ethernet 3. So what I'm going to do now is create another branch. So we'll work with branching again in the NetBox database. So we'll create a branch, and I think we call it deploy, CSR2. CSR2. So we create the new branch. Remember, it provisions for a couple of seconds, then it becomes active. And then I was just checking there that Ansible EDA is still listening for webhooks coming from NetBox, which it is. So back in NetBox, we will go into the branch. We activate it, and we've activated this branch now. So we're going to work again in a branch separate from the main NetBox database. Okay. So we'll select all these deviations. We've reviewed them, we're happy, and I'm going to apply them now. And when we apply them, we'll apply them to the branch, CSR2, and we'll apply those 5 deviations, which, if you remember, contains all this new information about the device we've just discovered. Okay, so they've now been applied to the NetBox database. And, they're still in the branch at this point. We haven't merged it yet. But if we have a look at the difference between the main NetBox branch and this one, we can see that we've got 5 differences here. That includes the interfaces, MAC addresses, and the host name and things like that, the actual device itself. And there's a bunch of changes that we are now ahead of in this branch than the main NetBox database. But ultimately, what I'm going to do here is just merge this data now. So we've reviewed it via NetBox Assurance. We've had a look at the branch. You could actually layer on change management on top of this with the commercial NetBox offerings. But the branch merging is now in progress. Remember, we're going to fire another webhook when the branch gets merged. And boom, you can see straight away the new webhook has been received. So this playbook, if you remember, was the one that pushes out all of that basic configuration. So the syslog servers, the name servers and things like that. You can see the inventory's been dynamically updated now as well, automatically, because we've got 2 devices in there, CSR1 and CSR2. That playbook has run without any hitches, which is obviously the great thing when you record a demo. You know it's going to work. And then if I go now to back to our SSH session, I'll SSH into CSR2. And yeah, just did a quick show run there. So you can see we've got I'll do a show run. You can see we've got all of our data name servers here. Obviously, host name has been pulled out from NetBox data. You can see our interface configuration. We've got the logging hosts. What else was there? I think we'll see it in a second. Yep, we've got our NTP servers there as well. So all of that data was pulled in from the configuration context data from NetBox, if you remember, and then pushed out using Ansible, using event-driven Ansible. And here's our device now. If we go back to the main NetBox database branch, here's our new device, CSR2, in San Diego, and we've pulled in. I think if you click on interfaces, yeah, we can see the interface information as well. So nice little run through there of hopefully something that can give you some ideas about what you can do in the network yourself. With event-driven Ansible. If you want to see some of that code, so there was the playbook code, there was the rule books that I worked with as well for event-driven Ansible. If you scan the QR code there, that'll take you to a Git repository with some code for the playbooks, etc. If you're interested in trying NetBox Cloud, you can actually get started with a free plan, which is free completely. It's limited in the number of devices and IP addresses and things like that you can manage. But it's a great way to sort of get a feel for the commercial offerings of the NetBox Cloud instance. And I think that is just about it. So yeah, thank you very much. Anybody, any questions? Yeah.
So for the merging,
Yeah.
is there a way to do like a control and approval or like change ticket values?
Yeah.
To make sure that
That's it. The question was about layering on change management on top of branching in NetBox. Great point. Yes, you can do change management on top of that with NetBox Enterprise and NetBox Cloud. It's not there in the community edition of NetBox, but it's there with the commercial offerings. So. Okay. Thank you very much, everybody.
All right. So I am loud. So guys, thank you so much for coming on Thursday. I know it's towards the end of the conference and everyone is really tired. How many people went to the party last night? How many people got up early this morning? So I actually wanted to go, but I had an 8:30 session this morning, and so I made the adult decision and went out instead. So I'm glad you enjoyed it for me. So thank you so much for coming and listening to me. I'm going to talk about using Ethernet for AI networking. WebEx app stuff, there's a whole lot of information here. You guys can go read this online. The backstory is I've been at Cisco 20 years, I did a bunch of Ethernet stuff, and I helped build the Catalyst 3850. All right, so I'm going to go through what's the problem, where are we, and what's next. And again, the goal here is to give it a taste, because I'm not going to be able to cover it all, but I want to give you enough context so you understand what makes sense. And Eric, if I stop making sense, it's your job to wave at me, right? Perfect. Okay, so we all know GNO is pretty expensive. Did you know it was that expensive? Accelerate, grow 103% in 1 quarter. The NIC markets are going to double. You guys know this one? 10 times the power. So just think about as we try and move everyone to ChatGPT, where's that power and cooling going to come from? Actually, a more interesting question is where's the revenue going to come from, but let's put that to the side. So Microsoft, a little while ago, they signed a 20-year contract to reopen 3 Mile Island. For those who don't know, that was the reactor that went bad. So they're 20 years out, they want nuclear power. A bunch of the hyperscalers are investing in small modular reactors because otherwise, even if they can get the power, they cannot get it to the data center. So you look forward for a while, these people are going to have small modular reactors next to their data centers. All right, so before Gen AI, in general, electricity use in America was declining. Now Goldman Sachs, now we can argue whether Goldman Sachs is a good predictor or not, but they are. And you can go get this on the slides, and down the bottom is all the links, right? So I'm not making this stuff up. Okay, so DC power is going up by 165%. So who designs big data centers here? Anyone? Right, no. Imagine you did. How would you actually manage to get that much power? How would you manage to restructure your operations to get that so much power more in, and how would you cool them? All right, so why does the network matter? So does anyone work in industrial building automation? Okay. So the automation rule in general is the process controller tells people to do something, they do it, and then they talk. So it's work, communicate, work, communicate. Gen AI training is exactly the same. You process, you notify, you synchronize. So if you look, for instance, at some of the big guys, they're looking at 50,000 GPUs. The work is split out. Everyone goes and does some work. But then you actually have to talk to everyone else. So this is an all-to-all communication, transferring probably gigabytes worth of data. The trick is until everyone gets it, you actually have to stop. So this is way different to a normal workload. Normal workload is pretty small, all the flows are small. This is a lot of very big flows with everyone sending to everyone, and if you don't, and you have to wait until everyone is finished. So what actually happens here is this becomes a jitter problem. For those of us who go back to voice circuit emulation, jitter is what is the variation in delay. So the worst case jitter slows you down. So imagine you have 300,000 GPUs waiting because we dropped a packet. That's a bad thing. And so we really have to build the network separately. It's a fundamentally different design. So I actually come more from enterprise networking, where we should optimize for idle because we're idle almost all the time. A normal data center workload, you're busy almost all the time. In this case, you're idle probably more than 95% of the time because the GPUs are doing the work. So you fundamentally designed it differently. All right, so here's the problem. So in general, us networking people, we think we're really important. But in reality, all we do is enable other stuff. So if you didn't see it, so my friend Eric over there, Eric Wave. Eric is the technical fellow who does architecture and design for Blue Origin. In that particular case, his network matters, because if it doesn't go well, things stop working. Now, I will think, you've had 2 successful launches so far? Okay, so you have to architect networks for the things. I also met a friend this morning who he designs networks for tanks. So the difference between the network has to be fit for service, and so they're very, very different to both the normal DC load and an enterprise load. So every amount of money that I spend, either power or time on the network, is the time I don't spend doing the GPUs. Which do we think costs more to run? Which is productive? So my actual goal is to make sure that I can run as much as possible. Now I'm idle almost all the time, but when I'm busy, I need to be 100% utilization to make this work. So throughput under full load. Now you guys know, right, in general in normal networks, ECMP sort of gets you right, but only gets you that way because you have a whole lot of small flows. What you have here is a whole lot of very large flows. And so I know the hashing doesn't work very well here. So throughput under load. Reliability. So I was talking to some of the hyperscalers at an event recently. They, in the copper and the high-speed copper links, they have different types of FEC, right? They have low latency FECs and high protection FECs. They always run the high protection ones because dropping the packet is a problem for them. They run copper because it's more reliable than fiber. Because if you have a very big system and you have one break, you may have to roll back to a previous stored state, which is very expensive. And power. Now again, power is sort of interesting because we don't actually need to be the most power efficient when we're busy, we need to be the most power efficient when we're idle. Because when we're busy, the network's busy, the GPUs are idle. So I actually have all the power I need. But what I need to do is be very power efficient when I'm not busy. So it's sort of a different way of thinking about the problem. Okay, so where are we? Okay, so there's AI network fundamentals. So the front-end network, this is your normal data center network. It has all the normal stuff, and I think this is where you probably end up moving inferencing. So this, you guys all know this. Okay, there's two things in the back end. There's scale-up network. This is what you'll see inside a rack, or if it's in the NVIDIA NVL72, it's between two racks. So this is very tightly coupled. So you have a bunch of GPUs, and the technologies in there are NVLink, Infinity Fabric, and a thing coming forward called UA-Link. These are very high bandwidth memory-to-memory transfers. These aren't Ethernet, they're not going to look like Ethernet. So these are actually highly synchronized, highly reliable, and it's all happening internally. So this stuff is fairly small and very expensive. And this is where the vast majority of links are going to be. And so you can take the photos, but it's in the PDF anyway. So the one I really care about is the scale-out network. So this is how I connect all the GPUs together. Now, in an NVL72, I don't know, there's like 300 GPUs. Google has plans to have a cluster of more than 300,000 GPUs. It's so big it's going to scale multiple data centers. So the real question is, how do I scale out that sort of structure? And what you find is the things in here are basically InfiniBand is sort of the thing people tend to think about. There's standard Ethernet and there's what's going to be called Ultra Ethernet. So UA-Link and Ultra Ethernet are vendor consortia, and they really exist to come up with alternatives to the NVIDIA specific protocols. Now, whether or not you like InfiniBand or NVLink, anytime you have a single vendor, we're not in a good place. So the goal is to come up with industry-supported, standard ways of doing this stuff that more than one company can implement. Now, we've all been through this path before. This will end up winning. I don't know how long it's going to take, but it will end up being the path. All right, so has anyone used InfiniBand? Cool. So this is what Google tells me. So InfiniBand really comes from some of the HPC places. And so what you tend to find is people will actually go and say, assume it needs the same types of interactions, but it really doesn't. So Google AI says, if you're optimized, you can outperform InfiniBand. When I was looking, I actually found, is there anyone here from WWT? So I found a nice article these guys had written. So the link's down the bottom. And so they're saying that the difference is actually statistically insignificant. Now, I think they probably tuned it quite well, but what you're really seeing is that it's a viable thing. Now, I didn't write this. I didn't actually, when I went looking for it, but the goal here is to give you context. So, what's the result of this? This is from some friends at 650. Ethernet ports and revenue versus InfiniBand. This is in percentage of 2029 ports. All right, so we know what's going to happen. It's going to be Ethernet. We don't quite know how that's going to look yet, but we know where it's going to go. So what's driving Ethernet? I mentioned scale. If you're building a cluster of 300,000 GPUs over multiple data centers, InfiniBand does have some scaling limits, but you also need a technology that you know you can get from lots of people. So I don't think in these cases, they're not really looking for interoperability, they're looking for replaceability. Because cluster 1 will have vendor A, cluster 2 will have vendor B, cluster 3 will have vendor C. They want the same function, they're probably not going to mix and match inside the cluster. That would make no sense. So if the only place you can get this stuff from is NVIDIA, then clearly your price negotiation skills are a bit sketchy. I think the other thing is that InfiniBand was designed for a certain role, and it's not really the right thing for the AI network. Where I think we as an industry make a mistake is we say new technology A has to replace B and has to do everything B used to do. And it's normally because we think when you change the network, you can't change anything else. However, if you have control of your stack, you can reimagine it. So again, Eric over there is my friend. He's doing a bunch of work in 82.1. You design your control loops differently because you actually optimize both the client stuff and the network to make them work together, which is why I think InfiniBand will not win because it's optimized for a different thing. Now, particularly these guys, the hyperscalers, they have total control of their stacks. So if they can rewrite a stack and basically reduce the cost of the network 10%, they'll do it. All right, so I talked about the size, supply diversity. I mean, NVIDIA have InfiniBand from Mellanox. Their stuff is great. They also do Ethernet. But no one wants to be in the case of a single supplier. So if I'm a hyperscaler, I'm going to go look elsewhere. Now, the same problem also applies for GPUs. So they've got to figure out a way to get AMD or whoever else going, because at the minute they are sort of hostage to NVIDIA. Now, I think that's got to change soon because they need to scale up and they need multiple suppliers. I'm a little surprised they haven't done it very much already because it seems to me like a software problem, but that's really not my scope. Okay, so we know over time Ethernet becomes less expensive to own and easier to operate, and everyone understands it. Now, Ethernet has changed a lot. Is there anyone here who actually has used ThickNet? Okay, so ThickNet originally was yay big, coax, and the way you connected to it was you put a spike through it. That was replaced by CheaperNet, which was a smaller coax connector with BNCs. Those ones, you're smiling, those ones weren't so nice, and actually a friend of mine, David Bumble, he has a YouTube channel, he actually built a network out of the old ThickNet to make it work, so that's a whole lot of fun to go watch. So, Ethernet, the really value proposition is it just works. We make it so it only does just what it has to do, and it's reliable and repeatable. So the speeds are scary. So at the minute in the standards, we are working on 800 gig and 1.6T. So the expectation from 650 for all of the RF speeds, again, so they're saying 50% up here is going to be 3.2T. We don't have it yet. It doesn't exist anywhere. So the expectation, they think we need to start having this available in scale by 2027, which is not that far away. If we look at the back-end network and the scale out, it's even worse. So they're saying 3.2T wins. We don't have it yet. And as soon as they do this, they're going to come back and ask for the next one up. So their expectation is that we just solve the problem. Now the trick is for industry is some of this stuff is magic. So it's going to be interesting to see how this plays out in terms of what we can build, which is deployable at scale. I can always build a Ferrari or Formula One car, but what I need to build is the equivalent of Camrys and Corollas that are going at 500 miles an hour. It's going to be a fun problem to solve. All right, does anyone know RFC 1925? Hello. It is the 12 truths of networking. The IETF puts out an April 1st RFC every year. My other favorite of this from there is actually ultra-low speed networking, which is worth reading. It includes using neutrinos and also using very big guns to send sound waves. All right. So the idea is he went through the fundamental networking truths. I think it comes from 1996. One size never fits all. So the hyperscalers in general are a bit like the service providers. They all do it differently. They all think they're right. So Google with its TPU infrastructure is quite designed to like Meta or Microsoft with different, because they optimize their TPUs differently. They built custom optical switches for the network with a controller, so they can actually restructure the network live, programmably. Now, so that means they actually build a lot bigger scale out. Their radix is a lot higher than many other people. Was this a good plan? It's sort of interesting. So you can go and actually read about their architecture, and it's really fun. Could you deploy it anywhere else? That's hard to say. But if you think about it, the investment in running these things is so high, this makes perfect sense. Meta is a rail-only design. Again, they're fundamentally designed differently because they have different beliefs on how these models will work. Again, you can go take a look at some of this stuff. There's a bunch of links down here. There's a company I really like called Semi-Analysis. They actually provide a really good free write-up where they sort of explain what's happening. So I tend to like them because it makes me understand it better. Okay, so what's next? Where do we go? Okay, you guys all run ECMP, right? Yes? And it sort of works fairly well. But you know the case where you have one really big flow and a bunch of small ones? It doesn't work quite so well. Why is that? Because generally it's an all-to-all, but the flows are pretty small, and we have a whole lot of entropy. So when we go to tunneling, for instance, like VXLAN or Fusion tunnel, what we end up having to do is we take the entropy from the inner packet to the outer packet. Otherwise, it would all be one big flow. If it's one big flow, ECMP just stinks. So it's, also, ECMP doesn't know about congestion. So what you end up doing is that if you get unlucky, flows will collide, and you get the case up here where you don't get through. because it's not aware, and usually there's almost no feedback. So ECMP is great when you have a large number of mostly small flows. It'll give you pretty good performance. But sometimes you might need to go tune your hashing, which a bunch of products provide, but it sort of means you actually know what's going to happen ahead of time. That's usually not the case for a normal data center enterprise network. So one choice for these guys is to run ECMP, but to tune it very carefully because they know what the entropy is to try and get better results. But it's a pretty clumsy technique. What we go to, and Cisco's a bunch of stuff online about this, we say a fully scheduled network. So if you look inside a big distributed chassis, what you'll find is there's a fabric between the line cards, and they'll run virtual output queues, and they'll run congestion management. We basically believe that that's the good path to run these networks, because what you can end up with is you can end up with 100% utilization all the time. Because again, for the AI flows, we're doing all-to-all with very big flows. They're transferring lots of gigabytes. So the real question becomes is how do I actually transfer? When I'm transferring, I need to be 100% utilized when I'm busy with no packet drops. So it really looks like you're building a big distributed switch. So we have a white paper out on this, you can go take a look, but basically the goal is to make sure that we get everything. So one of the things we do is we'll spray it across all the links and reorder on the way out. There's other things, there's multiple different ways we can solve this problem. We could also not reorder because the end device can reorder. And so part of the deal is to attack the assumptions that we don't need. So for instance, strictly speaking, because I'm an old, I first got my RFCs in paper, right? And it's where you subscribe to the service. So if you look at the definition of what IP is, it is an unordered, unreliable delivery service. At some stage on the way through, we made a decision that you can't reorder packets in the network, and that's like, it's actually a really bad decision because you can. It wouldn't matter because the end device will figure it out. TCP accepts this regardless. TCP puts stuff back in the window. So we actually end up doing a lot of really complicated stuff in the network to avoid a problem that doesn't exist. So a lot of the real question for this is trying to figure out what not to do, because if we don't do that, if we build everything, we'll fail. Okay, so we've done a bunch of research on this. Actually, we've built this with Silicon One. We have an in-house GPU cluster. It's not very big. I think it's like 256 or something. We've actually gone and built this. So the information's out there. We say with 16 jobs, we're twice as fast. All right, so if that's true, and I'm dealing with 300,000 GPUs, so maybe I've reduced the time that they were idle from 5% to 2.5%. On a job that takes 2 months, that is enormous. All right, so there's a whole lot of people doing stuff. I chair the Ethernet Alliance, we're a vendor group. We're trying to actually get people all do the same thing. Because you always run into the risk with a bunch of standards groups, they all go off in a different way, they all try and solve it themselves. See, there's a really good XKCD cartoon from a while ago, which says, the situation is we have 15 competing standards. It's horrible, like let me go and get one that covers them all. The result is 16 standards. So the trick here is to get everyone to actually play their position. Imagine if you would a soccer team that's full of Cristiano Ronaldo. It would totally suck because he wouldn't want to play everything. The trick here is to try and get everyone to do the thing they're good at and nothing else. So in 802.3, they're writing 200 gig per lane standard, and they have an exploration group to try and figure out how to do 400 gig per lane. Now, 400 gig per lane, I started with 10 mega, is just magic, right? It boggles my mind to think about it, but one of the good things I have is I'm actually a computer science major with a physics minor, and I like quantum mechanics. But it's just a 400 gig per lane. Okay, OIF. OIF does a bunch of technology problems. They're off doing signaling. SNIA and the SFF committee, they're trying to figure out how you would do some of the basic signaling stuff. Ultra Ethernet Consortia. So this is a very large group of vendors trying to come up with an alternative to InfiniBand. Now, there's a lot of work going on. They're supposed to have the first spec out any day now, and they have a very broad scope. My guess is that some of the things they're defining we won't end up using. So they're putting everything on the wall, and we have to figure out what actually happens. The Ultra Accelerated Link, there's sort of an adjacent thing. They're trying to come up with a replacement for NVLink, and I think they're actually based on Infinity Fabric, and they define 200 gig per lane for 1,000 accelerators within a pod. So if this is within a rack with 1,000 accelerators, you can imagine the building this thing. And when you go look at the data, the power and cooling requirements, this is just stunning. All right, so there's lots of stuff happening. Next rule. You're not done until there's nothing left to take out. And this is a great rule for every document you ever write. It's a great rule for your network. So one of the worst things for people inside Cisco supporting networks is everyone has it differently. Don't be clever with your network, do the simple things. If it doesn't have to be there, don't do it. So often what happens with standards is people want to put it in different bits and pieces, and so you end up with a complicated standard where a bunch of stuff doesn't work. If, for instance, if you are a Cisco customer and you're using the same things that everyone else is using, you're pretty safe. If you're the only customer using a feature, maybe not so safe. So the trick is only do the stuff you absolutely have to do. And this is the way you can actually deliver stuff in time. And Eric knows this, right? If you do the wrong things, it's like doing the right thing at the wrong time is bad. Doing a cool thing that makes your network more complicated is bad. So the trick for us is to figure out and do just what we have to do. Okay, so Ultra Ethernet Consortia, Cisco's the founding member. We basically want to make it work to be replaced InfiniBand and everything else. Now again, being somewhat of a cynic, what you needed for HPC and what you need for other things is slightly different. So I suspect we're going to address the back-end scale-out network first, because that's where all the volume is. Whether it replaces it for other use cases, I think is a little less relevant. All right, so let's look at the options for running your Ethernet fabric. Everyone knows this, right? We all run our networks like this. We know the backwards and pros and cons. If you've got lots of entropy and you've got lots of small flows, it works pretty well. However, it's not great. If you've got lots of big flows, you can easily get all the flows on one link. All right, so let's say I want to enhance Ethernet. A bunch of people, what they're doing is they're doing flowlet switching. Does anyone know how this works? We already have it in our products. What you do when you're transmitting is you basically keep track of what the time in the network, and if a given flow is idle for more than that time, you can rehash it. So it makes your flows very short, which is going to get you better hashing. You can also do like a spray and reorder in the NIC. That works as well. So you can adjust the distribution based on congestion. So these are cool, but they also tend to you need a quite invasive control system to make them work. Ultra Ethernet, they're going to do packet spraying. They're also doing some interesting things like they're doing link level resiliency, because they believe that's going to help. They're running congestion management. So this is going to get you a much better result. And this is really targeting to have effectively what you can get out of InfiniBand. We believe that scheduled Ethernet is better. I talked about this a little earlier because we have a much better utilization. So this is where we believe scheduled Ethernet, which we can do today, gives you twice as good performance. However, it may not be what we can get the community to agree to. So one of the things at Cisco is we need to build a single playing field and win inside the playing field. But you guys all know, we all do standards plus. Yes, we do the standard, but we have a better option over there. If you want to be fully compliant, replace with someone else, do the standard. But you can use ours for this. I think this is easier in the AI world because there's only one vendor inside the pod. No one's going to base an AI switching pod with some Arista here and some Cisco there and some something else. That would make no sense. And the performance of these guys doesn't depend on the traffic utilization, because I no longer have to have this thing of each flow has to go the same path. All right, what's the net-net? We will become the dominant technology. Now, I'd written this slide before I went to talk to the analysts. And so those of us who've been around for a while, we've seen Ethernet win. Actually, here's fun. Does anyone have an opinion why Ethernet won? Because at the time, there was lots of competitors. There was ArcNet, there was Token Ring, there was DECnet. So there's a very good book about 3Com, the story of 3Com. So 3Com was a company founded by Robert Metcalfe after he left Xerox. It's the first Ethernet company. Now, the original Ethernet, it's called ThickNet, was this big. We talked about this before. Now, the reason they put it that way was the design was to basically run a cable down the center of a corridor and spike into it. So, When 3Com first designed a cheaper NetNIC, they got really excited. And so they rang up Steve Jobs and said, Steve, come down here. This is wonderful. It's going to replace LAT. You'll love us. Yeah, Steve Jobs came down. You guys read anyone read the autobiography, the biography of Steve Jobs? So I'm not going to say what he said, because that would get me in trouble. But he basically says, what is wrong with you guys? Why don't you put it over the phone wires? So what that did was you could actually use the infrastructure that was there today. Now, was it because it was the best technology? It was the one that you could deploy. So my argument is you need to figure out a way to deploy stuff at scale. We'll do just enough. So we're going to go through this whole thing with UEC and we'll figure out just what we have to have. When we first rolled out voice over IP or video, it was really hard to tune your networks. There was all this special stuff and now it just works. So over time, what we see is we simplify the load to match the network's capabilities. The trick here is we have to do this faster, but the hyperscalers have full control over their entire stack. So imagine that we did all this, but InfiniBand was 25% more effective. They would run InfiniBand because the cost would not matter. We need to be, if we can be the same performance, we win. If we can be better performance, we win. Now, for better performance, we can actually charge more because any minute we save and give to the GPUs is enormously expensive. So, we're going to win. The real question is deciding what not to do. The trick is to make sure the network does just the things it has to do and nothing else. That being said, I have a minute and a half to go. I have a couple of questions. Take it away. Hello, sir. All right, so this was from Greg, and Greg was from WWT. And if you saw earlier, I quoted your blogs from it. So the real question is, how much are we going to replicate the InfiniBand function? I think your particular one was replication deduplication, which is really reliable delivery. So yes, there are plans to do this. Personally, I think we won't end up needing to do this because I think that will become an end device problem. You only do this if your application depends upon it. But if your application doesn't depend on it, you wouldn't. So let's imagine, for instance, you have a GPU thing connected to two entirely different switches. The replication deduplication only really works if the output is on one switch. I'm better off doing that in the end device. So I think that comes under a thing we don't really need to do in the network. Does that make sense? So again, our goal has to be, do the things that only the network can do, because everything else you can do somewhere else. Unfortunately, as an industry, we tend to want to do everything, so we want all the value. But in this case, we have to actually play a good team sport, because if we all try and play center forward, we're going to fail. We are at 1 second left. So guys, thank you so much for coming. I appreciate it on Thursday. I'll be around to talk. And also take a look at the slides because everything is linked down there. This will give you more context. Again, thank you so much.
Okay. Well, good morning, everybody. Hope everybody enjoyed the Cisco Live celebration last night.
I'm Ed Novak. I'm from the network platform team. I'm a technical marketing engineer on the workflows platform. And if you're here to hear about automated Meraki Switchport configuration copies for switch lifecycle replacement, you're in the right place. So with that, let's go ahead and get started. So you can join the WebEx discussion for WebEx space for this session through the app. If you're looking for the slides are not available in the session details. You have to go back to the main menu and go to My Session Files, and that's where you'll find the slides once they're posted. And if you have any issues there, please reach out to me through the WebEx space. So again, I'm a technical marketing engineer. 25 years ago today, I started working for Cisco Systems. So I've been here for 25 years. I'm now officially a networking antique. But for the last 10 years, I've been doing network orchestration and network automation. I also like collecting certifications, and a year and a half ago, I started this new thing doing marathons and ultra marathons. And I used the same skills from doing my certifications. I developed a training plan, I stuck to it, and I got through that. And actually, 1 month ago, I finished my first 100K event. But don't worry, I'm not going to have you guys lace up your shoes and come with me. But I am going to talk about network automation from an ultra runner's point of view. So before we click on this run button to run this workflow, we're going to ask some questions that I ask about events that I'm looking at evaluating to take part in. So first thing is, what are the race details? In this case, what is workflows? And the registration, what's the cost of that? And you're going to like the answer to that question today, I guarantee it. We take a look at the course info. In this case, we'll do a deep dive through the workflow. We'll review the FAQs. I look at the aid stations that are going to be on the course. So where are there opportunities to learn more about workflows here at Cisco Live, for example? We'll do a race review if I can. In this case, we're going to do a live demo today so you can show this workflow in action. And of course, you got to make sure I make the cutoff time. My clock's running right down here. So let's get started. So race details. What is workflows? So I think a few of you have heard of workflows before, but most of you have not. So for those of you who have not heard of workflows, workflows is a cloud-hosted automation solution from Cisco that is now going to be native inside of the Meraki dashboard. It's meant to be a low-code, no-code automation environment. So simplicity, drag and drop for creating and editing automations. There's an exchange there, so you can take pre-built workflows and run them as is. You can modify them to meet your needs, or you can be fully custom from the ground up. And even though we're hosted inside the Meraki dashboard, workflows is not just for automating Meraki tasks. You can automate tasks across the Cisco domains, whether it be Catalyst Center, Catalyst SD-WAN, ICE, integrate with third parties like ServiceNow, and we also have an AI integration. There's an exciting demo down in the world of solutions. We'll show an AI agent using a natural language conversation with a user to select and run a workflow. And this is all about reducing and eliminating those repetitive manual tasks to reduce those errors in data entry and accelerate your adoption of automation. So this is all part of that Cisco unified platform strategy. As you heard about on Tuesday during the keynote and you're seeing now, the colors on the Meraki dashboard have changed from green to blue, and it's starting to get more of a common user experience from Catalyst Center to Meraki as well. So both those things are coming together. We have that common API strategy, common policy strategy, and this is part of our common automation strategy across Cisco. And again, even though we're hosted in the Meraki dashboard, we're not just for Meraki automation. You can automate your tasks across the Cisco domains for Meraki, Catalyst Center, SD-WAN, ICE, and so on. And I mentioned before, integration with third parties like ServiceNow. There's a Git adapter there as well. And you can connect to those on-prem controllers as well for automations. We have that exchange that'll have automations in there, so you can utilize them pre-built right out of the box and run them. If they don't meet your needs entirely, pull them into your environment and customize them, modify them to meet your needs, or start from the ground up and build a fully custom automation using our low-code, no-code, drag-and-drop simple environment. We have that exchange. So here's that comprehensive catalog where you'll have Cisco-managed automations available to you. There'll be submissions from partners and from the community that Cisco will take in, we'll validate those, and we'll put those in the exchange as well. This is the same exact concept we have on the security side in XDR Automate. Underlying this is the same basic automation platform for workflows as on XDR Automate. So it's that common unification of a common automation platform. These will be based upon the Cisco validated designs, and we're going to start regularly updating those. You have your workspace inside of the workflows environment here. So here's where you have a chance to see the status of a workflow, the owner of it, the details, and you can do your collaborative automation here. You can easily duplicate a workflow, edit a workflow, and share it. You can export it as a JSON file, and again, import any simple workflow JSON file into your environment. Workflow editor, so this is kind of the really magic inside of the workflows. On the left-hand side over here, you see a list of activities, and these are grouped by Cisco domains. So for example, we have Cisco Meraki there, Catalyst Center, Catalyst SD-WAN. These are where you find all of those individual activities. You can just select, click, drag them out onto the middle canvas right there. You can easily click and drag to reorder them if you need to. And then right-hand side, you've got the details. In addition to the actions, you also have ability to put logic in here. So you have things like loops and conditionals that again are drag and drop, point and click simplicity. If you want to get into the low code environment, there is a Python module you can drag out there to do local Python scripts. That Python will be able to do data manipulation for you in a custom way. It won't be able to reach out externally because it's isolated inside the workflow environment, but you can pass data into it, have it manipulate that data, and provide that data as output that you can then easily map into following activities in your workflow. And one of the exciting things we're showing downstairs in the world of solutions is AI integration of this. So as our catalog of workflows grows and grows, you can have a natural language conversation with the AI assistant right in the Meraki dashboard. Tell it what you want to do, it'll check the catalog, provide you with a workflow that'll be appropriate for your needs, and then provide you with prompts to help guide you in selecting the proper inputs for that workflow and getting it to be executed. And now the big question out there is registration. What's this going to cost me? And the good news is nothing, okay? This is a value add for being a Cisco customer, so there's no risk to adopt this and deploy it. This gives you access to all those Cisco adapters and automations from a networking community-focused team. So let's dive into what the course looks like. In this case, what does that workflow look like? So this workflow is meant to copy Meraki Switchport configurations when I'm doing a lifecycle replacement, especially if I'm moving between different Meraki device models or a Catalyst switch, for example. So I have 5 basic inputs here, and starting from the second from the bottom, I have a Boolean value here, which is all ports. And so if this value is set to true, it's going to copy all ports on the source switch to the target switch. If that value is set to false, then it's going to look at the inputs provided for the source port ID and the target port ID. And the other 2 variables we provide in here are the 2 device serial numbers. Now I chose to input this information as a input value. I could have easily rewritten this workflow and just say run it. The workflow could have gone out, collected information about the switches on my network, and then presented a user form here where the user could have a drop down to select those particular fields. One of the advantages I have of doing this way is I can actually copy switch port configuration information between networks, or actually between networks in different organizations, because all it takes is the serial number and then the API key of the user. So as long as my user has permissions into different networks, different organizations, this will work beautifully. So this is what the workflow looks like. Now don't worry, it's kind of a little bit of an eye chart, but it's actually very, very simple. At the top we have 4 steps. We're doing some basic data configuration information, and then we drop down into our conditional, which we check that all ports Boolean. If it's going to be true, on the left-hand side we loop through all the switch ports. If it's false, on the right-hand side, we copy the configuration for that single switch port. Well, let's take a deeper dive into what these actually look like. So here are our common actions. Again, these all come from that palette on the left-hand side. I just click and I drag those out onto my canvas. I have that atomic operation up there that's going to get my complete source switch port information. Then I'm going to read things into a table to create my configuration information and set my port count variables down at the bottom. So taking a deeper dive into this, that first atomic action where I'm going to get my source switch port information. This atomic requires just one simple value passed into it, and that is that input serial number. And in the yellow box right here, I have my variable mapper icon. And if I click on that, it brings up my variable mapper. And so here I can easily go into select the workflow input, source serial number. I can also have selected a previous activity, and we'll show that a little bit later on, but that's it. And I've now mapped that value into that atomic action. That will go out and retrieve the full configuration and pass it into the next step here, which I'll read that information that comes back into a JSON table. So this takes a little bit of knowledge about JSON, but again, I just drag this read table from JSON activity onto my canvas. I have to specify the path, and here I'm going to look at the full JSON path. That's what's up top there. And then at the bottom down here, I need to specify what JSON I want to pass into that. So I click on my variable mapper, highlighted in yellow, It brings up my variable mapper right here, and so here I can say activities, and this is the second activity in my workflow, so there's only one activity before it, so I select that one, and I grab the output. And that's done, and then I can select which type of columns I want to read. Here I want to read the port IDs, so I'm going to grab the port IDs from that JSON. I do the same thing for the target switch information, and I built tables then of my source switch configuration and my target switch configuration. And then I want to update a couple local variables to have for some conditional testing later on in my workflow. So I drag out a set variable activity, and again, I have my variable mapper right there. I map in this case, I'm updating a local workflow variable, and then below that, I click on the variable mapper icon, and I can map in the activity from the output of when I read data from my JSON table. Very simple. Then we talked about we have that Boolean, so we have a conditional here where we're going to check that Boolean value. If it's true, we want to copy all the ports on the switch. And then we need to make sure that our switch configurations kind of line up. We want to make sure that our source switch has equal to or lesser number of interfaces than our target switch. So I can't copy a 48 port switch to a 24 port switch. This is meant for doing it equal 24 to 24 or 12 to 24, for example. But then we're just going to loop through every single interface on that source switch and copy the configuration over. This does have one caveat right now that it only operates on Meraki port IDs that are numeric. So some of the Meraki uplink interfaces are alphanumeric, so that does going to take a little bit of modification on that workflow, but it's pretty simple to do that. And then at the end, we set our result message. So taking a deeper dive into this conditional. Again, here's my conditional logic. I drag it out onto the canvas, drop it on there. The first thing it's going to ask me is what property I want to evaluate. I have my variable mapper right there, and I can select which value I want to map. In this case, I'm going to map in the Boolean value for the workflow input, the all ports Boolean, and then I'm going to select what my comparison value is, and then the value I'm going to compare it to. I can either have that be a static value I can enter manually, or again, I have access to that variable mapper, I can map it and compare it to an additional value. For this one right here, this is a Boolean value, so when I have that drop down here, I only have two options. I can either have it equal or not equal to a Boolean. If this was an integer or a string value, I have additional comparison operators. But again, this is all done with no code. Let's just click. Then we get into our loop logic. So I drag out a for each loop. So way up at the top up here, you'll see that for each. So this is a for each operator. I just dragged it out there. I only need to provide one argument to this, and that is going to be the source array I want to iterate over. And again, I utilize my variable mapper. I select that. In this case, I look at the previous activities, or I read the source switch configuration information, and I grab the output from that. Pass it right in. I'm done. I'm now going to loop through every single interface on that source switch. Now, I do need to start grabbing some information from that tables I built to pass in for the configurations. So here I'm going to be selecting information from a table. The first thing I have is my input table. Again, I map that using my variable mapper. I do have to specify a where clause, so I'm going to specify the field I'm looking for, and then I'm going to use my variable mapper to pass in the loop ID. So I want to map that port ID to a certain loop ID, and then I want to read the column. In this case, I want to read the port ID for the target switch, so I can grab the information of the port ID on the target switch that I need to update, and I can select the result columns there by, again, pulling my pull down here. I have the ability to select all the options, but right here I just want to grab the port ID on the target switch, so I need which port to update. Do the same thing for the source switch information. So again, we're going to read the entire source port configuration. So we're following the same steps here. We map in, using our variable mapper, that input table. We specify the where clause, so identify what row in the table we want to grab, and then what are the result columns we want to grab here and select. And again, we want to select the entire configuration for that port. So we just really select the all box right here, and it's going to grab all the information from that row for that port configuration. And we can pass that into our Switchport to do our update, and then we can update our variables at the end. So again, I dragged out the set variable information, dropped it onto there, use my variable mapper here to identify which variable I want to update, and then I can manually enter in data that I want to update, or I can have it be a variable I'm going to be updating from. And I can also do mix and match. So for some of my strings on here, where I have a new value and I want to provide a more detailed message to my user, I have detailed information. I'm copying the port configuration from port 1 to port whatever came out of my loop, because this is looping through all the interfaces on the source switch. But in the case that we have a single port where that all ports Boolean is false, this one here is just going to check that those source and target ports are valid. You don't want to try to grab port 25 from a 12 port switch, or update port 25 on a 24 port switch. So we got to make sure that the values the user provided to me are valid. And then we just do the same operation. We copy the switch port configuration and update our values. So looking at that conditional logic, again, I drag and drop out that conditional activity onto my canvas, and I can start specifying what conditions I want to evaluate for. Again, that property, I click my variable mapper. It allows me to select which variable I'd like to update, and then I can start making selections for that comparison. So my port ID, it's an integer value. So I can say I want to make sure that the source port ID is less than or equal to the count of the interfaces on that switch. And I do the same thing for the target switch. And so these are ANDed together by having that top radio button where it says all conditions must be met. And I also want to make sure that neither port ID was 0, so I AND those in there as well. If I have the case where I want to do an OR operation, I just make the second selection up there, select any, and that automatically converts into an OR situation. And this is what it looks like at the end of the result of the workflow. On the left-hand side, my all ports Boolean is false, so it's looking at the individual port IDs that were passed in, which are underlined that in red. Again, in orange, we have the 2 serial numbers, and in the bottom, we see our true result, so that's succeeded. And then we have our message here. That message was I copied port 1 to port 1 from the source switch, the target switch. On the right-hand side, when that all ports Boolean is true, is shown in red. Again, we're going to read in the 2 serial numbers. In this case, we're going to ignore the port IDs because we're going to do them all. We have our green result there. We succeeded in passing the configuration from one switch to the next switch. And my message down here is I copied all ports from port 1 to port 10. So that's a lot of information, but now we understand what the course looks like. Let's take a review of what the frequently asked questions are. So like, when can I get access? How do I access this? And is there a community to support this? So the good news is you can scan this QR code or grab this URL, and I'll be putting this information also into the WebEx space for this session today as well. But this is how you can request early access. And we'll be turning this on an organization by organization basis inside the Meraki dashboard for you. So I'll give you guys a minute to take another picture of that and scan that QR code. That will take you to an MS form you'll fill out, and then the team will be in contact with you to identify your organization ID so we can turn that on for you. So this right now is available in the US region, but very shortly we'll be rolling it out to the rest of the regions that host a different Meraki dashboard. Again, if you're going to be integrating with any on-prem controllers, you will require a remote VM, but for Meraki, everything is native. And again, access right now, early access is turning on right now, and then we're going to be GA later on this year. For support, in addition to reaching out to me in the WebEx space for this particular session, we also have a community site on Cisco.com. So communitycisco.com, search for workflows. I'll be posting updates there regularly when new information about the product has been released, as well as posting the recordings from all the sessions here at Cisco Live once they're released as well. And great way to ask questions. If you have an interesting use case, you're not sure quite how to automate, post about it in there. If it's interesting enough, we'll take it into Cisco team, we'll develop that and then release that as a Cisco managed use case for you. When I'm also looking at my ultra marathon, I also want to know what the aid stations, what's out there to help me finish my race. In this case, where can I learn more about workflows here at Cisco Live? I mentioned it before, we have a demonstration downstairs in the World of Solutions. They can show you how AI integrates directly into workflows, also show you some additional workflows we have beyond this simple switch port configuration copy. There's also been a number of sessions here at Cisco Live. Unfortunately, those all took place earlier this week. But again, the great thing is those will be available on demand, and I'll be posting links to those recordings into the Workflows community site as soon as they're available. Okay, I got a few minutes left, so let's jump into a race review. What does this actually look like in a real life system? Okay, so here is Meraki dashboard. Let me just refresh this to make sure I'm still connected. And the one thing you will notice is down here on the left-hand side is a new tab, this automation tab. I'm going to change my organization. So this automation tab, that's the workflows environment when it's turned on for your particular Meraki organization. So again, we have that list of activities right here, that exchange, that's where information will be published about different workflows you can then grab and import into your environment. You have your workspace, that's our main working area. So let me jump into that right now. Here I have all workflows that are available to me. We have atomics, which are kind of like functions that can be easily included into workflows. I'm going to jump into my favorites, where I've got a couple selected here. And I want to take a look at my first one here, my MS-120 to a 225. And I'm going to select that workflow, and I'm going to run that workflow. And again, I'm prompted here for information, the source serial number, and I'm looking here at my all ports Boolean is false. But before I get started, let me jump into the Meraki dashboard, and I'm going to refresh that one over here so I can show you that I've got nothing up my sleeves here. So here is my network. I have my 120. It's got configurations on it for port names and tags and stuff like that. My 225 is below that. Nothing's been configured on it. So to start with, I'm going to run with that false option. So this is only going to do the single port. So that's going to run. In just a second, it's going to finish. And we're going to jump back into the Meraki dashboard over here. And I'm going to refresh, and you're going to see port 1 on the 225 here is going to be updated. So we refresh. And now port 1, look at that. Ed actually knows what he's doing. That workflow actually succeeded and copied that switch port configuration. So now I trust this workflow from this Ed guy. So let's go back and run that workflow again. This time let's take a gamble and change that false to true. So this is going to do all the switch ports. So we're going to run that. And you should notice while this is running, any activity that's currently in progress is highlighted in blue. Ones that have been completed are in green, and I've got the ability to come in here and look at iterations while it's running, or even once it's completed, I can go back in and drill into a loop operation, for example. I can select which iteration of that loop I want to drill into. I can select details on a particular task, and I can look down here at the output information for that particular task. So here is the switch port configuration that was grabbed from that particular iteration of the loop where we were reading the table information for the switch port. So I've got the ability to go down and deep into the values there. And so once that workflow completes, we come back over here, we refresh, and all my interfaces have been copied over. And that's great and wonderful if I'm going from an MS to an MS. But what if I have a catalyst switch in here? Good news is this will work for catalyst switches as well. So I'm going to jump over here. I have a different organization, a different network that has a catalyst switch on it. And we can see here that nothing's been configured on it. And I look over here, and I have an MS-120 with a port that I want to copy the configuration from. I'm going to jump back into my workflow environment, jump into my workspace. I'm going to select my favorite, and so I've got a 120 to 9300 catalyst switch activity that I am going to run. And this time I'm just going to run with false. We're just going to copy a single port because that's just a proof of concept, but we're copying port 5 on the 120 to port 5 on the 9300. And again, I can see the status of the steps as they're running through there. Blues are in progress, greens are completed, and in just a second, that is success, that's been completed. I can come back up to my 9300. And remember that this is my 120. I had a port name and some tags and stuff like that configured on it. I jump back over here, and we refresh. And boom, my configuration has been copied. So makes that idea of replacing Meraki switches very, very quick and easy. I no longer have to go port by port, manually updating them. Prone to errors. I can run the workflow like this and save myself a ton of time doing things. So let me pause right here and see if there are any questions out there in the audience about workflows I can answer for you. You got to speak up because I have a really hard time hearing over the noise. Yes, so you can also utilize workflows to feed variables in. Our new environment supports global variables as well. We have a partner that was using the earlier version of workflows, Red River. They gave a presentation at Cisco Live in Amsterdam where they did a demonstration about how they have a workflow that reaches into NetBox, pulls configuration information from NetBox, deploys Meraki networks, and then pushes the information back into their live documentation that gives them like their WAN IP and stuff like that once the network's been deployed. So they've had a lot of success doing deployments that way. And there's a link to that recording in the Cisco Workflows Community Forum for the previous Cisco Live. Any other questions out here? Yes, sir.
Does this work when you're performing a hardware refresh going from CAT to Meraki?
So if you're doing a hardware refresh from CAT to Meraki, I actually haven't done that, but the APIs are the same. So if we're able to copy from Meraki to Catalyst, if that Catalyst is Meraki managed, then we can copy from Meraki or from Catalyst to Meraki. There's another question back over here.
When is it going to be generally available?
Okay, the question was when will workflows be generally available? Our target right now is later on this fall, probably around the September timeframe, but that depends upon if we encounter any issues or the feedback we get from the early field trials, but our goal is to have this generally available before the end of this year. So with that, let me jump in. I got a couple more slides I need to take care of. I've got to make sure I make my cutoff time today, so let's get through that. I'm going to pause right here and ask you to please complete your session evaluations. So while the Cisco Live speakers, we all compete against each other to get a high score, actually I'd like you to do is complete your evaluation to help Cisco Live become a better event for you. So make sure you talk about what sessions are important to you, what's the content that's important to you to help make Cisco Live better next year. And if you complete the minimum number of sessions, surveys, and the master survey at the end, you can get entered into a chance to win a free pass to Cisco Live next year, so you can come back and enjoy all the excitement. Also, we're going to tell you, continue your education. The great thing is, as Cisco Live winds down, we do have all the sessions available on demand, and I'll be posting the links to those in the Cisco Workflows community page. And also, if you want to reach out to me by email, my email's here. So reach me by email, reach out to me on the WebEx space for this session, or reach me through the Workflows community space on Cisco.com. Everybody attending a Cisco U session is being asked to scan this and complete a quick little survey on AI skills. So please, if you wouldn't mind, take a moment, scan that, complete that survey for Cisco U, help us gather some information, and help us give you more information next year at Cisco Live. So again, thank you so much for your time today. I'll be downstairs in the World of Solutions at the Workflows demo down there if you want to come down and conversation. Talk to me about your use case. I'm really interested in what are your automation challenges that we can start helping you to build those Cisco managed offerings. So thank you very much.
All right, we might make a start, everyone. Thank you so much for coming. My name is Chris Gascoigne. I'm a Principal Solutions Engineer in our Cloud and AI Infrastructure Architecture team. You can probably guess from my accent, I'm not from the US, I'm from Melbourne in Australia. So it's really great to be here with you all today. This session, we're going to talk about AI infrastructure, and what I'm going to try and hopefully get across to you is not just what are the aspects of AI infrastructure, but more importantly, why does AI have different requirements on the infrastructure? What are the kinds of situations where we have those different requirements, and why do those requirements exist? So let's start off by talking about AI infrastructure. And the first thing I always say when I'm talking to organizations about the infrastructure to support their AI applications is that it really isn't a one-size-fits-all approach. And I think this is really important because a lot of people see these kinds of images from NVIDIA's GTC conference that they have every year, talking about these massive tens of thousands of GPU clusters, supercomputer clusters in giant data centers. And these are really important and really have a lot of use cases for specific organizations. But for most organizations, this is not what they want. For most organizations, that's really analogous to a Formula One car. And as anyone who's watched Drive to Survive probably knows, you don't just go out and buy a Formula One car. You actually have to build a Formula One team, which is very complex, very expensive, and requires lots and lots of people with very, very specialized skills. And so when we're talking about the infrastructure to support AI applications, what we should really be thinking about is what do we actually need for my organization and for my use case. And in some cases, it might be the Formula One car, but in many cases, it might be something much simpler and much easier to get started. It might be a scooter, it might be a bike, it might be a regular car. Where on that spectrum do you actually fit? And to answer that question, you kind of need to know a little bit about how these AI applications actually work and how they drive the requirements into the infrastructure. And so I always like to go back to first principles when trying to answer these questions and actually understand, well, how do these AI applications actually work to have those different requirements on the infrastructure. So let's talk a bit about that, a bit about how these AI applications actually work. So I'll start off with this. So this is the first thing that any AI engineer or data scientist who's building out a new AI application and a new use case will start off with. They'll start off by deciding what is the architecture of the model that they're going to use in that application. And this is a very, very simple example. This is about as simple as it gets. This is known as a multi-layer perceptron. And this is a very small version of that. But this is still relevant. Even if you look at the large language models in use today, things like Llama from Meta and those kind of models, they still incorporate the multi-layer perceptron architecture inside those much larger models. So they're still very, very relevant today. And the basic premise behind these models is that we're going to, when we get to inferencing time, we're going to be passing our data through this model and getting some output at the end. But before we do that, we need to train this model. And the training process, basically what we're trying to do is, on this model, every single one of those linkages is essentially a weight. It's sort of how much influence does one neuron have on the input to the next neuron. And when we're doing the training process, essentially what we're trying to do is optimize those weights so that our model produces good output in a wide variety of scenarios. And so the way that we do, or the data scientists do that training process is through the training process. And basically during training, because you know what you have a bunch of data, training data that has, you know what the inputs are, and you also know what the outputs are going to be, we can do things like this. So we start off by taking a sample from our training data set, apply that as the input to our model, run that through the model, and we get an output. If it's a classification problem, we'll get a label. If it's another type of problem, we might get a different output. But we get some output. And the first time we do this, because the weights on this model are not initialized, typically they're initialized to random values to start with, the output that we get the first time is going to be complete and utter garbage, completely incorrect. But because we're still in the training phase, we know what the correct answer should be. So we can actually look at what the model output, which is wrong, and what we expected the output to be, because we're working with our training data set at this point in time. And we can actually compare those two against each other. We can compare the expected output and what we actually got from the model. And then through what's known as backpropagation, we can calculate the error between those two things, between the expected output and the calculated output. And we can propagate that error backwards through the network. This is known as backpropagation. And essentially what backpropagation is doing is sort of taking that error and working backwards through the network and working out, well, which of those weights in the network had the most influence on the incorrectness of the output. And so then we can get a sense of, well, this weight had a very big impact, this weight had very little impact on the error that we got at the output of that model. And then using those sort of gradients, as they're called, we can do the optimization step. So the optimization step basically looks at all those gradients that we learned from the backpropagation phase and goes through and tries to update those weights just a little tiny bit every single time, update those weights so that we'll get a better result the next time. And then we just keep doing that process, we keep doing that process over and over again, a few thousand times, a few 100,000 times, a few million times, a few billion times, depending on the size of the model, depending on the size of the training data set. We do that over and over and over, optimizing a little bit each and every time to make our model perform better and get more correct outputs. Now that all sounds relatively simple, probably not really simple, but relatively simple when we're talking about a fairly small model like this. But when we start talking about large models, very, very large models with very, very large training sets, we need to think about how can we take that training process that I just spoke about and distribute that across a cluster of nodes so that we can do our training jobs in a reasonable amount of time. Because there's no use having a training job that's going to take 3 years to complete. You need that training process to be much, much quicker. And so most of the time what you end up having to do is do distributed model training. And when we're thinking about the distributed model training, essentially what we're trying to do, we're trying to start off with our training data and our untrained model that we talked about a moment ago. We're trying to produce a trained model, but we're trying to leverage multiple nodes to actually accomplish that. Now, those multiple nodes could be multiple servers, it could be multiple GPUs in a single server, doesn't really matter at this point. And essentially what we're trying to do is work out what's the best approach to actually do that. How do we distribute that training workload across multiple nodes so that we can improve the performance? There's a few different ways that can happen, that we can distribute the load across multiple nodes in a training sort of environment. There's a couple, there's ones called model parallelism, which kind of breaks the model up across the different nodes. But the most common and sort of building block for this is known as data parallelism. And the basic idea with data parallelism is that when I want to distribute that training process across my multiple nodes, I'm going to use the data, segment the data across all those nodes and run the training process in parallel. So in this example here, really simple example, we've got our training data, we've got 3 nodes in our cluster, might be 3 nodes in a GPU, might be 3 servers, doesn't matter. We've got our 3 nodes, and what we're going to do is take that training data and break it up so that each of the nodes is working on a third of the data set. So the first node gets the first third, second node gets the second third, and the third node gets the third third. And then what's going to be happening is that each of those nodes is going to be doing that training process that we talked about on the whole model. So we're not breaking up the model in this case. Each node is working on the entire model itself, but using a subset of the data, and that's how we're going to do the distributed. But the question becomes, okay, if I'm doing this on my 3 nodes here, each of them working on a different section of the data, essentially a different data set, and they're training the whole model, how do I get that to produce a single model at the end? I don't want to get 3 different models, I want to get one model that incorporates the learnings from the entire data set. How does that actually happen? So I'll talk through how it happens in a GPU sense, and I'll go through this a couple of times to hopefully make it clear. So let's just go back a step and think about how we would do it on a single GPU in a single server first, and then we'll scale it up from there. So we've got a single GPU, we've got our model uninitialized at this point, and it's exactly like I spoke about at the start. That GPU will run the forward propagation phase where it runs the training data samples through the model forwards, calculates the error in the output of the model. They run the back propagation phase where they propagate the error backwards through the model and work out the gradients of all the weights in that model. And then the optimizer runs to update all of the weights in that model based on the gradients that we learned through back propagation. So that's how it works in a single GPU. Now let's come back to data parallel across multiple GPUs, in this case 3 again. Now the first example, I'm going to show you how it doesn't work. So this is the way that doesn't work, but the naive approach that you might think about. The naive approach you might think about is we have our 3 GPUs, we have each of those GPUs working on a third of the data because we've got 3 in this case, and we run the forward propagation on all those GPUs, we run the backwards propagation, and then we run the optimizer step on all of those GPUs. But because they're all working on different sections of the data, all of their new trained versions of the models are completely different. So we have that problem where we have 3 different versions of the models that we get. One that has the learnings of the purple data set, one that has the learnings of the orange data set, and one that has the learnings from the red data set. So how does it actually work? How do we do this in practice in a way that actually works, that produces a single model that has the learnings from the entire data set? Well, the way this works is the first 2 steps are the same. So with the forward propagation on each GPU using their own subset of the data, the backwards propagation, take the error, propagate it backwards through the network and calculate the gradients. But here's the difference. In in data parallelism, what actually happens at this point in time before the optimizer starts is that there's a synchronization step that occurs across all those GPUs. And this is known as an all-reduce operation. And essentially what that means is that we want to reduce the three different sets of weights that we have across all those data sets. We want to reduce those to one set of gradients, sorry. And we want all of the GPUs to receive the same set of results. So we basically want to average, is the easiest way to think of it, average the gradients across all these three GPUs and distribute that average across all the GPUs so that they're the same. And the way that this is done in most environments, in an NVIDIA environment, is through the NCCL, the NVIDIA Collective Communications Library, implements this all-reduce operation across these GPUs. And it does it in this ring approach that I'm showing on the slide here. So instead of just sending all of the gradients to one GPU, having it do the average and then send them all back, because that would be very data intensive on the network, it actually uses this ring algorithm to do this synchronization step, where essentially what's happening is it will send a third of the data to the next one, and they'll send a third of the data to the next one, and they'll be averaging as they go. And it's a much more efficient way of doing that average operation. But now, essentially, at this point, what we have is that all of the GPUs have the gradients for all of those parameters in the model, but they're all the same because they're all an average of what each GPU has learned. And now, each of those GPUs then runs the optimizer step, just like we spoke about before. But because they now have the same average across all of them, when the optimizers run on each of those GPUs independently, they all produce the same result because they're all working from the same set of inputs. And so now we're all in sync. And we just keep doing that process again and again and again with more and more data to get the fully trained model. But the important point here, if I go back to this step, the important point here is that this synchronization step that happens between all of the GPUs is really, really important, because while this synchronization step is happening, all of those GPUs are essentially idle. They're not doing any calculations. They're essentially waiting for that synchronization step to occur before they can run that optimizer. And that's why GPU to GPU communication is really, really important in these training workloads. And it's also why we use this ring topology, which has an impact on how we build the networks as well. So if I jump forward, talked about that. Okay, so that's training. Inferencing is obviously much simpler. We all probably know that already, probably not news to anybody. But with inferencing, we already have our model architecture. We have trained weights for that model architecture that we've built up through our training process. And in the inferencing phase, obviously all we're doing is basically putting in our data on the left-hand side and getting a result, or a prediction, sorry, on the right-hand side based on the weights. So the input goes in, goes through the model, and comes out with the prediction. And that's all we need to do in inferencing. So obviously it's much less intensive process. I do want to touch briefly sort of a bit of a higher layer concept on this idea of retrieval augmented generation. If you haven't heard of retrieval augmented generation, you probably will fairly soon. This is an approach that enables, specific to large language model use cases, it enables you to, augment a pre-trained model with your own data without going through a training process. So it's a really important point that I think a lot of people might be misconstruing. In a retrieval augmented generation system, a RAG system, there is no training that happens. It is all inferencing. We're essentially trading off, instead of doing lots of work at the training time and doing less work at the inferencing time, with RAG we're doing more work at the inferencing time to get an output that is more relevant to your organization as if it was trained on your own data. And the basic way that RAG works is that we have the large language model over here, just like we're probably all used to, but instead of just sending the user's request directly to the large language model, what we want to do is actually look up the information that's relevant to the user's question from some database and provide that to the model along with the question. So it can basically answer questions about information that wasn't in its training data set. And the basic way we do this is we use an embedding model to understand the context of the user's question. We use that embedding model to look up the relevant information from a vector database. And we then, based on what comes out of the vector database, we work out which are the most relevant results. And then those results are passed to the large language model along with the question so that it can generate the output. Now, the obvious question when we talk about RAG like this is, okay, that makes some sense, but how does the data get into this vector database? And to do that, we go through an ingestion process where we basically take a bunch of documents that we're interested in, chunk those documents up into pieces that make sense together, whether it be paragraphs or sections or something like that based on the document structure. And then we use the embedding model to understand the context of each of those chunks and insert it into the vector database. So it's very much like an indexing process, not a training process. But there's a few things to note about this. The first is obviously, like I said, all of this is inferencing. All of these models are just doing inferencing. We're doing inferencing even at the indexing stage, that ingestion stage. We're using the embedding model and the vector database to actually do inferencing at that point to do those steps. And what you probably want to do is make sure that this, at the very minimum, the embedding model and the vector database, that should be close to where the data actually lives. That's really, really important because you probably don't want to be sending, gigabytes and petabytes of data, up to some cloud service using a REST API. It's not very efficient, very, very expensive, and you've got to keep doing that over and over again every time those documents change or every time there's a new document added to the repository. So that's retrieval augmented generation. All right, so let's come back and talk a little bit more about the actual infrastructure. I put this in here. Everybody obviously knows, when we're talking about AI and ML, we probably want to use GPUs to do both the training process and the inferencing process. I guess the point I wanted to make on this slide is that that's not a new idea. That's not something that NVIDIA just decided a couple of years ago when ChatGPT became popular. This is a slide from NVIDIA from 2007 talking about why GPUs are very useful in AI ML use cases. And it basically comes down to the fact that all of those, the inferencing operations and the training operations that I was talking about, they all basically can be decomposed into a series of matrix multiplication operations. And GPUs are very, very good at matrix multiplication operations because that's essentially what they were designed to do. So that's why GPUs are very, very good for doing AI use cases. And so when we talk about the infrastructure required to sort of support these applications, I put this together as a sort of completely genericized version of the kind of infrastructure that is typically used in these AI environments. There's a few things, I guess, to highlight here. So I've got a few servers. In those servers, at the top, you can see they have CPUs like any regular server. Those CPUs have NICs attached to them, regular NICs connected via PCIe to the CPUs, and those NICs connect to a front-end network, which is, we're all familiar with these kind of networks. It's where our management connectivity lives, it's where our connectivity to the outside world lives, it's where our storage in many cases might live, although not necessarily. Cluster management, Kubernetes, control plane nodes, all of those things will live on the front-end network. And then down the bottom here, this is where all the GPU stuff happens. So in this case here, I've got 3 servers, and I've sort of said each of those servers can have multiple GPUs, 2 GPUs, up to 8 GPUs, depending on the type of server. But there's a couple of differences. The first is that the GPUs inside the server have an intra-host interconnect, a sort of dedicated network to connect those GPUs together inside the server. In an NVIDIA scenario, that's something called NVLink. In a AMD scenario, that's something called Infinity Fabric. In an Intel scenario, they actually use Ethernet for that connectivity between the GPUs. And that's great for that all-reduce operation between GPUs that are in the same server. But if you're scaling that training job across multiple servers, then you need some way for the GPUs to talk to each other across servers. And NVLink doesn't really work in that way, and Infinity Fabric doesn't really work in that way. And so typically what you'll have is the GPUs will have dedicated NICs to connect to a special back-end network that is just used for connecting those GPUs to each other. And this is where the bandwidth and the speed of these networks really comes to the fore, because like I said before, when we're doing that all-reduce operation, the longer we wait for that to complete, the less efficient our GPUs are going to be because they're waiting, they're not doing any calculations while that synchronization is actually happening. And so that's why these NICs are dedicated to the GPUs. They're typically directly connected, so you'll notice the GPU has a direct connection to those NICs, their own dedicated PCIe connection. They don't go through the CPU or the host operating system. And they typically connect to these back-end networks at 400 gig and 800 gig fairly soon as well. So let's talk about when do you actually need that interconnect between the GPUs? When does it matter? Obviously it matters for training. I think we sort of talked about that quite a bit, and hopefully that's pretty clear. But when it comes to inferencing, do I need a back-end network? When do I need an NVLink between my GPUs from an inferencing scenario? And the reality is the answer to that question depends on the model that you're actually looking to inference. So if you're, I've got 3 examples here, and these are all based on Llama 3.1, just various different sizes of the model. So the left-hand side, we've got Llama 3.1, 8 billion parameter version of that model. And with floating point 16, FP16 precision, that model takes about 16 gig of GPU memory to inference. If any of you have sort of looked at this stuff in detail, you're probably saying, well, what about the KV cache? What about all these other things? I've got a big asterisk down here. We're ignoring all of that for simplicity. We're just going based on the model weights. So it's going to take about 16 gig. And if we've got a server that has 8 GPUs and each GPU has 80 gig of GPU memory, well, we can fit that model easily into a single GPU. In fact, we can fit multiple models into a single GPU at that size. And so in that case, GPU to GPU connectivity is completely irrelevant for inferencing. There is no need for one GPU to ever talk to another GPU. It's a purely horizontal scaling problem with nothing shared between any of those GPUs. If we go to a larger model, let's say we go up to the 70 billion parameter version of that model, again with FP16, that means we're going to need about 140 gig of GPU memory. That no longer fits on a single GPU. It has to be spread across multiple GPUs, but still fits within a single server. So in this example here, we can fit 4 versions of that model across those 8 GPUs in that server. But in this case, the connectivity between those GPUs inside the server does matter in that scenario, because there will have to be some passing of the parameters between the 2 GPUs. And then when we go really large, let's say we go to the 405 billion parameter version of that model, well now we can't even fit that in a single physical server. We actually have to extend that model across multiple servers, across 10 GPUs across 2 servers. And so in this case, the server to server GPU interconnect has an impact. And so that's kind of the point. Depending on the size of the model, in some cases, the intra-host and inter-host network is irrelevant. In some cases, the intra-host network matters, but the inter-host doesn't matter. And in very large scenarios, they both matter. And you have to think about both of those things. So when we're talking about those back-end networks and what can be used there, I want to talk about the requirements on that back-end network. What is different about that back-end network compared to the front-end network or traditional networks that we're probably all quite familiar with. And again, I like to go back to first principles and think about the why of some of these scenarios, because a lot of people say things about these back-end networks without ever actually understanding why those requirements exist. And a good example is everyone says, well, back-end networks need lots of bandwidth. Okay, that's true, but why? Well, I think we've explained why. That all-reduce operation that we talked about before that synchronizes across those GPUs between the hosts, the longer that takes, the longer the training jobs are going to take, and so bandwidth between those GPUs actually matters for that reason. And it's actually getting worse. I put this in here because I found this in a paper that as the model sizes get bigger, the amount of data transferred on the back-end network is going up 6 times faster than the size of the model. So if the model goes up by 1 megabyte or 1 gigabyte, the data transferred between the GPUs goes up by 6 gigabytes. And so the back-end network, the ability to transfer gigabytes of data from GPU to GPU becomes really, really critical. And from a network perspective, what does that mean we need on the network? Well, obviously we need lots of bandwidth, so we need 400, 800 gig switches and switch ports. But more importantly, we need to make sure that we can actually fully utilize all of that bandwidth in our fabric. So we need to have really good load balancing across our fabric. We don't want to have a situation where we might have, 800 gig of bandwidth between two GPUs, but because all of the flows collide on a single link and we get congestion, we're actually getting less bandwidth available. So that's why things like dynamic load balancing, static pinning, advanced ECMP are really, really important. The second requirement that's always thrown out about GPU networks and back-end networks is they have to be lossless. Well, firstly, that's true, again, and the reason it's true is because the the way that that NCCL operation happens to get the data from one GPU's memory to another GPU's memory, it goes over RDMA. And RDMA doesn't handle packet loss very well. That's ultimately what it is. And it doesn't handle packet loss very well because it doesn't have a very good retry mechanism. It has to wait for a timeout, and then it has to say, go back to the last packet that I saw, and retransmit everything from that perspective. It has like a go back N mechanism. And so when there is packet loss present in the network, the performance goes down quite a lot. This is again from another paper I looked up. In a AIML training environment, even 2% packet loss can cause the training jobs to take 8 times longer, which is pretty significant. You know, if you had a job that was supposed to take an hour and now it takes 8 hours, well, that's pretty annoying. If it was supposed to take a month and now it takes 8 months, that's not really sustainable, is it? So packet loss is important. That doesn't have to mean it has to be 100% loss. It just has to mean that packet loss is not routine in that environment. And the good thing is, from an Ethernet perspective, we know how to solve this problem. We solved this problem 15 years ago. Priority flow control, explicit congestion notification is the answer. You'll hear DCQCN talked about, and that's really just a description of how to use PFC and ECN together to achieve this outcome that RDMA over converged Ethernet actually needs. The third one is latency. Latency is important in AIML networks, but it's actually not as important as people talk about. It's important that the latency is consistent because we want to have good traffic flow across the network, but it actually, the ultra low latency is not critical in AIML networks because essentially what we're doing is bulk transfers between GPU memory of very large amounts of data, gigabytes of data. And the latency actually doesn't have much of an impact on the performance of that. So it's more about consistency of the latency rather than the absolute lowest level of latency. And I put in a fourth one here as a surprise, because people don't think about this, but operations is really, really critical on these back-end networks. Because if you've got a back-end network that's supporting $10 million worth of GPUs, and that network is underperforming or deployed incorrectly or down, and your GPUs are not being utilized, you're literally setting money on fire. Because you have these very, very expensive resources that will be underutilized because the network is not performing. So automation, visibility, telemetry, all those things that we do in Nexus Dashboard are really, really critical to these environments. All right, so just a couple of quick key takeaways. Like I said at the start, make sure you understand the workloads that you're going to be deploying and think about the infrastructure that will support those workloads correctly. It's not a one-size-fits-all approach. I find a lot of organizations that I talk to, they mention the word AIML and they get 50 server vendors descending on them saying, how many 8 GPU servers are you going to buy? And that is not the right approach. What you should be thinking about is, what is my use case? What does that mean from an infrastructure? Is it primarily inferencing? How large are the models? What's the usage going to be? And I can work out a much more optimal solution for those kind of customers. Don't get distracted by the latest shiny object. You see these NVIDIA GTC presentations, they look amazing, and they really are, but come back to reality, think what's actually required in your environment, what's going to align to your existing infrastructure strategy. And then finally, take advantage of some of the stuff that we've already done. We've got validated designs, we've got AI pods, Hyperfabric AI, these kind of solutions that make it easy to get from I've got a use case to here's the infrastructure that's needed to actually support that, and a validated design on how you deploy that to get the outcome without the risk. So last thing, please complete your session evaluations, really, really important. I'm sure you've heard that a million times already. In terms of continuing education, obviously, we're sort of at the end, so make sure you check out the on-demand session. But I put in my email address down there. Feel free to email me, send me a message on WebEx Teams. More than happy to answer any questions that you might have from this session. Otherwise, I will say thank you very much for coming and enjoy the last little bit of Cisco Live before you go home. Thanks a lot.
All right, cool. Awesome. So welcome to one of probably the last sessions that you'll see at Cisco Live. So thanks for making the time to come and spend time with us. What we're going to go through in the next 30 minutes is going to be Hypershield in a nutshell. How many people have heard of Hypershield? If you haven't heard of Hypershield, I'd be wondering why you're here. But basically what Hypershield is a next generation security solution that Cisco's come out with. So next 30 minutes, myself and my co-presenter, Errol Roberts, are going to go through what Hypershield is, what it consists of, and how it works. So anybody who's ever seen me present at Cisco Live will know that there's always going to be a picture of a rocket or a high performance aircraft in my presentation because A, I really like rockets, and B, we put a hashtag on here called high bit rates. We got a lot of material that we're going to go through in the next 30 minutes, so we will dive in and get started. They put a Cisco WebEx app slide in here, but I'm not absolutely sure that there is a WebEx room for Cisco U sessions. However, if you want to contact Errol or myself, our email addresses are in the presentation and you can always reach out to us. So by way of introduction, my name is Dave Sachs. I'm a distinguished engineer with Cisco. Been with Cisco coming up on 26 years now, 26 years, which basically means at this point I'm part of the furniture in the company. I've been there a long time. Inside Cisco, we say we live in dog years. So if you're a little dog, that's 5 years per year. If you're a big dog, that's 7 years per year. So on that basis, I've been with Cisco anywhere from about 125 to 175 years so far, and I'm getting the receding hairline to prove that. I'm joined today by my comrade in arms, Errol Roberts. Errol, you want to introduce yourself? Okay, I will introduce Errol, then I get to roast him. Errol's been at Cisco a very similar amount of time that I have. Based out of New York City, he works with obviously a large number of major accounts within New York and worldwide. Errol is an expert in several different areas, but one is around measurement, around operations and efficiency, and around security. Errol and I actually worked in the same team on a security innovation CTO team. Now, I have a hypothesis based on the following. One of my favorite actors passed away last year, James Earl Jones, which I was very sad to see. But I believe that he has, at least his voice, has been reincarnated in the voice of Errol Roberts, which you will hear when Errol starts to talk. You can see if you agree with me. He actually has the voice of Darth Vader, or, I think Errol has a much better voice to listen to than my voice, right? So, proceeding on from there. One of the things we're going to talk about with Hypershield, and one of the first enabling technologies we're going to talk about in Hypershield, is eBPF. How many people have heard of eBPF before? Yeah? You're aware of what it is, what it does. Basically, it is a way for us to instrument the Linux kernel. Cisco acquired a company called Isovalent last year. Isovalent was one of the leaders in the field of eBPF. So basically what eBPF provides for us is the ability to instrument the Linux kernel. So when we take a look at that, what we're effectively doing is making the kernel programmable. We can make dynamic changes into the Linux kernel. Now, why is that important? Well, the Linux kernel, as you know, is the heart of the operating system. It's the most controlled code space within the operating system. If we're going to execute things within the kernel or insert new code into a kernel, that typically takes years for that code to be not just constructed, but qualified and accepted into a Linux kernel for deployment in the Linux system. That means that typically kernels change, or what's in the kernel changes very, very slowly. However, the kernel is the highest performance place to run code in the entire system. It also has visibility to everything the system is doing, so it's ideally placed from an observability point of view and a security point of view. So what eBPF gives us is the ability to insert code into the kernel. Now, to really appreciate what that means, we need to take a look at how operating systems work. If we think about, a server, network, storage, memory, et cetera, and then up top we've got our applications that are going to run on it. The applications can access the hardware directly, can they not? No, they cannot, right? Applications never talk directly to hardware. There's always an intermediary in an operating system that allows that hardware and those resources to be fairly shared among all the applications that are running on top. So those applications are going to make system calls to access the underlying hardware. All those system calls are going to operate through the kernel. Those system calls give us various different things that we can take a look at, and these are all the types of things that we can pull out with eBPF. So eBPF itself stands for Enhanced Berkeley Packet Filter or Extended Berkeley Packet Filter. Doesn't really have much to do with packet filtering anymore. but it is a way for us to dynamically and safely insert code into the Linux kernel. So things like for doing things like observability, security policies, network filtering, we can insert code to pull telemetry out of the kernel. We can also insert code with eBPF that will, what we call compensating controls, which will allow us to control what happens. So for example, if I don't want a particular process to be able to access a particular file, I can insert a control in using eBPF into Linux kernel to prevent that from happening. So it's not just about pulling data out, it's also about pushing capabilities or controls into the kernel. These are some examples of what we can do with that. By the way, you notice I'm not sitting here reading the slides. I find it really, really annoying when I go to a presentation and a presenter puts up slides and then mechanically drills through all the bullet points on the slide. If you see anything up here that I'm not talking about, stop me and we'll go through it. But basically I'm going to talk about what's on the slide or what the subject matter at hand. So effectively what we're able to do, for example, from a network filtering point of view, we have knowledge within eBPF of the Kubernetes layer, so the container layer that's operating, a container hosting layer that's operating within a device. But we also, underneath that, have access to the network stack, we have access to the file system, we have access through the kernel and those system calls that are being made to the kernel to everything that's happening on the machine, right? This is an example of some of the stuff that eBPF can see, and you can see that this is very, very comprehensive. We could take a look, for example, anytime a process runs, anytime a process spawns another process, anytime a process opens a file, reads a file, writes from a file, closes a file, anytime a new network socket is opened, anytime packets are transmitted, we can see and trap virtually everything with eBPF. If you want to know all the details about eBPF, I highly encourage you to go out and just go into Google and punch in Learning eBPF, Liz Rice, L-I-Z Rice. Liz Rice is one of our people from Isovalent. She wrote an O'Reilly book called Learning eBPF, which goes into extreme detail, where you can go in and you can take a look at what does it take to write your own eBPF code and insert it into the kernel. eBPF functionality has been in the Linux kernel for several years now. The eBPF code that you insert into a kernel runs through a verifier step to make sure that the code is quote unquote safe, meaning that it won't, we guarantee that the code will run to completion. It won't just introduce an endless loop, which of course could hang the system. There are various other steps to qualify the code to make sure the code is safe to operate on a machine, but fact is eBPF can see a lot of stuff that's going on in the machine. Now, eBPF in and of itself is really cool. I remember the first time I saw eBPF and I thought, wow, this is awesome because it gives us visibility into the host that we never had previously. We never had that ability to drill down into host and extract all of this data. A lot of time as network engineers, we're looking at data on the wire. So what's the problem with taking a look at packets on a wire today? They're almost all encrypted, right? And unless we're going to decrypt the traffic mid-flight, which has its own set of issues and challenges, we're typically not going to be able to tell much about, for example, traffic that's running on port 443. It's all encrypted. I can't tell what's inside of it. But if I can pull eBPF data out, I can now see, well, what process opened that socket, what data was read to be sent over the network. I could start to tell a lot of things that I can't tell just from sniffing the packets on the wire. So one of the things we started asking ourselves is, well, with all this capability in eBPF, what if we could leverage what's in eBPF to build this kind of dynamic and hyper-distributed security solution across the infrastructure? And that's effectively what we built with Hypershield. So Hypershield is designed as a system that leverages eBPF as one of the foundational technologies, but we go over and above that, and Errol's going to talk more about this. We install an agent on the system called the Tesseract Security Agent, TSA, right? We all went past a TSA agent to get here at the airport. This is very similar. In this case, we have a TSA agent that's running on the machine that gives us the ability to pull out all sorts of telemetry from inside the machine and also to insert compensating controls. So for example, imagine there's an exploit that comes out. I need to block that exploit, but I don't have a code upgrade that would block that particular exploit from running on the machine. I could use eBPF to insert a compensating control such that that particular exploit will not be able to execute on the machine. It's what we call a shield, pushing an AI shield down onto the device. So this is one of the reasons we need to use AI in this context is The good guys, all of us, have AI, but so do the bad folks that are out there, the bad actors. What the bad actors are literally doing these days is when threats come along, those threats are being fed as exploits, or those vulnerabilities are being fed by the bad actors into an AI system, and a generative AI system spits out a way to exploit that particular vulnerability within a couple of minutes. And that, we're reducing the time to exploit the vulnerability now from weeks or days, which it used to be, literally down to minutes. We need to have an AI-based system that can generate a compensating control in a similar amount of time. That's what we do with Hypershield. So, addressing some of our problems around segmentation, around patching. How many people have ever generated a patch, pushed a patch out in an environment and had something go wrong when you push out a patch? Yeah? Or push out a policy into an environment. Once bitten, twice shy. It makes you very concerned about, hey, I'm going to push patches out in an environment. That's why patching is hard. The actual mechanic of generating a patch is easy, but the potential impact or downside of that can be hard. It's really easy to do an own goal on that. And change in an environment is always, or there's always a risk associated with change. So we have some unique capabilities within Hypershield that allow us to not only generate policies adaptively, but to push those policies out in such a way that we minimize risk of exposure in the environment. I'm not going to steal Errol Thunder because he's going to tell us exactly how we do that. So, with Hypershield, this is kind of the architecture overall of Hypershield. We can see, we've got the platform that goes into it, and the system fundamentally is AI native. It is cloud native. It's built on open source eBPF, and it's designed to be hyper distributed. Do you remember in the keynote on Tuesday, you saw our executives talking about new platforms? We're introducing new Nexus switches, new Catalyst switches that had security coprocessors and data processing units, DPUs, built into them. That's allowing us to take the functionality that we have in Hypershield and distribute those down not just to enforcement points on the host, but enforcement points in the network as well, what we call network enforcers. So with that, I'm going to turn over to my friend Errol, who's going to walk us through how all of this works in detail.
Thank you. Cheers. Yeah, so let's dive in. So one of the things that Dave mentioned is really more leveraging the telemetry that you get from eBPF. So one of the things that we do leverage a Ansible and Tetragon library to feed the Tesseract security agent. What that does is that for every event that's occurring, where you're looking at file changes, you look at process changes, you're looking at networking connection, we take that telemetry and then we build a graph, an application fingerprint. That's massively important, because at the end of the day, what you want to be able to do is to understand the behavior in a much more dynamic way and be able to apply policy relative to the changes that occur in real time on your application host and also in your infrastructure. So one of the things that we are doing there is actually getting the telemetry in, mapping all the behavior patterns, building you an application fingerprint. That fingerprint is going to be critically important in terms of the use cases that we intend to drive afterwards. So with this fingerprint, what we are able to do with that agent is really to provide a characterization of what's happening on that particular workload. And that's possible by taking advantage of the telemetry with eBPF. Now, if you look at this example where you're looking at communicating from workload A, talking to workload B and C, traditionally we would have just put a firewall in between A and B or B and C. And typically we'll block on our 5-tuple, we'll look at the TCP port numbers, and that's it. The reality is that we have no awareness of what process is actually originating that particular connection on that particular port. So by having this characterization at the workload level, you can make your policies now much more granular. And you can actually also reduce the amount of policy constraints within the network enforcement point as well. So what you're seeing here is that now that I have this visibility, I can say only the HTTPD process can originate this connection on port 443 talking to workload B, or only the MySQL process can open this network connection. So now you can go write a policy at the host level. Dave mentioned tracing policy, that you said this particular process can open this particular connection on this particular network address. So what we have done actually in order to facilitate this is actually come up with a common policy model. We call it a PART policy model. It's a principal action resource. I'll go through that a little bit. And the intent there is really to bring workload policies and network policies much closer together. So therefore, now if you're going to think about what's changing within the environment today, most customers are looking at writing policies against labels. They don't want to write policies against IP addresses. If you go beyond the label, then you can now write policies directly more from a process perspective. The other point here is that once you have a deeper characterization of the policy construct within your host, then you can actually optimize the network enforcement policy as well, because your much more granular policy is on the host side, and then you have a network enforcement policy that corresponds. The view here is that if you only had just the network enforcement point policy, as your workload move across the infrastructure, you have to make sure you can distribute the same policy wherever the workload is moving. So one of the advantages of the Hypershield system is really more centralization of policy. So therefore, all your network policies, all your host-related policies is stored centrally. You can push those policies to the various enforcement points depending on the type of enforcement. So there's different types of enforcement. There's a host enforcement capability that's here. So when you think of that telemetry that's coming from that individual host, what we're doing is that we're building a dependency map or building a graph on each individual host. Dave mentioned the fact that the system is distributed. That's really distributed nature. So with eBPF as an example, and leveraging eBPF, now every node that has this eBPF capability becomes an enforcement point, so you can apply security policy on that particular individual device or that particular enforcement point. Today it's really on your workload enforcement point, but you can imagine it could be any component. I think during our keynotes, as an example, we mentioned that we're leveraging this technology within our Nexus portfolio, or Catalyst portfolio, to deal with exploits. And the intent there is really to say, hey, look, if we have this capability, as an example, we can deal with vulnerabilities much quicker. Same applies when you're looking at a workload. So the view here is that you have your local graph in a particular host. You have a local graph in a particular host here as well. So we take those graphs, those individual graphs, and we merge them into one bigger graph. The other thing that we're doing as well, we announced a set of smart switches. Those smart switches has the ability to build a local graph as well. Not there today, but it has a local graph. The intent is there to really watch what flows are going through the switch and then kind of recommend network policies for you based on the actual behavior. So you're going to put your set of guardrail policies, but we're also going to show you here's what's really happening within the switch in order to complement the behavior. So what we do then is actually take IP fixed telemetry. If you, let's say, have a load balancer between or other device that may be obfuscating the original IPs as an example, by taking the IP fixed telemetry, we can now look at the end-to-end behavior pattern from host A to host B in this example, and then recommend the set of policies that you need throughout the environment. The other piece is that by having a dependency graph, we can now look at local attacks that are occurring on a particular host, but we can look at multi-step attacks or multi-host attacks as an example, because you'll get process level visibility in terms of what's happening on this host. You'll get process level visibility in terms of what's on the other host as well. So now you can apply security in a much more granular way. So we're looking for single step attack behaviors in a particular host. We can now look at multi-step, multi-path behavior. So if you have, let's say, a process that may be nefarious and, let's say, reaching out to multiple different systems, you can look at the behavior graph to understand what is happening and is there malicious intent occurring just by analyzing the behavior from a graph perspective. So that's one of the benefits there. The graph also helps us to derive policies. So by having the graph, we can then derive policies from the graph. Now, Dave mentioned the whole notion of autonomous segmentation. The idea is that by having a graph that's changing, you can now update your policy constructs relative to what you have available to you. One of the other things that Dave mentioned to you before is really more when we think about change within the environment and change control, one of the things is really what we focus on is really more a digital twin construct, right? So the idea is that as we make software updates, both what we do internally from a testing point of view, but when we ship software to you for your network enforcers as an example and the various enforcement points, can we test and can we test also in real time? So if you think about the smart switch as an example, it has a notion implemented in there of a digital twin behavior where essentially you can have two copies let's say if you think about the virtual instance as an example, it's 2 instances of a virtual network enforcer, where you have an active data plane, a shadow data plane as an example, and for policies, network policies that you want to test, we can be testing those policies with the real live traffic, then we simply not execute on the shadow data plane, but as your live traffic is going through, a copy is actually being executed in the secondary policy plane, so you can see what that policy result would be. Similarly, when you think about it from a software update point of view, we could be loading a second version of software in that shadow environment for us to then kind of compare to see what's the behavior of this software stack versus the other software stack, to make sure to give you confidence that the upgrade is going to be executed well. Also, your policy changes are going to be take effect. So we do a lot of statistical analysis in the back end to kind of ensure that we can provide that capability in order to give you much more of a confidence score in that sense. Now, the system works on-prem or in a public cloud, so therefore there's a set of enforcers. Example, we talked about the host enforcer, that was the Tesseract security agent. You have a network enforcer, there's a virtual machine-based enforcer, and that's really for environments where you're not allowed to put a host, or you can't put a host agent. Then you want to say, hey, I want to apply policy as close to the host as possible. So if you have a virtual machine type environment, so this would be a virtual machine, virtual-based enforcer, similar to firewall, but from an L4 perspective. So it's basically applying policy at the network level. The other type of enforcers that we announced is really a switch-based enforcer, where we're bringing basically the switch performance, but the L2, L3 capability, couple that with a firewalling capability or L4 enforcement capability into one common device. So therefore allowing you to simplify your infrastructure. When you think about your infrastructure deployment, a lot of customers may have a firewall, they may have a L2 and L2 in between as an example, or different networking stack in between. That could be collapsed into a single device, and now every port on that particular device can give you a set of stateful L4 network services. So scale from a throughput perspective, over 800 gig, and certainly you have a lot of ports there in order to be able to build a much more rich infrastructure. And that's controlled via the controller, so the user controller to push the policy onto that particular enforcement point. So with those enforcers, what we're allowed to do is address a set of use cases. One of the use cases is more for L4 zone segmentation, so we're relying on our network enforcers to do that. As an example, so that smart switch that I just explained to you before, you'd apply that in for DCI connection. You may in turn for internal network zones where you're looking just for L4, you're not looking for L7 capability. You may use that the cloud edge to simplify your cloud edge connectivity. And when you think about the telemetry that's coming from that eBPF, that Tesseract security agent, now you can begin to solve problems around segmentation in a way that's much more dynamic. And also at the same time, you can also be able to look at problems around distributed exploit protection in terms of how you can apply a compensating control or shield in a much rapid time frame relative to what we're exposed to today. So just kind of looking at one of the use cases, if you have one of these smart switches as an example, what you can see is really a collapsing of function. You can see where you can reduce the size of the infrastructure, you can begin to simplify, so basically embedding a network enforcer, L4 enforcer, with an L2, L3 switching device. One of the initial use cases from one of the customers, as an example, that drove this is, hey, I'm at my cloud edge where I'm connecting into my multiple cloud providers as an example. It's just a small component where I may be having MACsec terminating on the back end in my connection to my cloud provider, but then I'm doing high performance filtering at 800 gig as an example from a performance perspective, filtering at L4. When my traffic hits my data center, I may not necessarily need to run those flows through a DMZ again. If I want to do L7 inspection, I may choose to do that, but I'm not necessarily at the force through an L7-based infrastructure from an inspection perspective. For a lot of customers, it's really more about simplification of the environment. With that same device and other device that we have announced, we have the ability to say you can apply it from a DCI connection. You can also apply it internally within your zones. And what we're doing is adding the same technology into top of rack switches. So in the future, as you build out, let's say, a VXLAN EVPN infrastructure, that could be a TOR, and then you'd have additional firewalling capabilities within the TOR before you hop onto your VNI, your L3 or L3 VNI within that within that fabric. The other use case is really more around autonomous segmentation, and for that, you've seen this picture before. Certainly what we're looking at is all the telemetry around process behavior, network flows, known application behavior that we have anonymized. So let's say we know certain specific behavior application patterns that goes into our understanding of the backend. So what we do with that is to say, hey, look, as we discover your individual environment that's happening on a particular host, you can apply a set of guardrail policies as an example. So you can say, hey, look, these set of hosts, these set of processes on a particular host have common shared services, similar here. What we then do is actually look within each one of those restricted zones and then look at the dynamic nature of what's going on to recommend a set of policies for you. Once you recommend those policies, you can either choose to accept those policy changes or you can let them be a part of the baseline. But the idea here is to be able to react against what's happening within your application environment in a much, much more dynamic way. And similar, what we do here is that we recommend a policy. We'll say, hey, look, recommendation could be for shared connections, you have an allow policy, or you may have a block policy as an example for something that we intend that may not be the right approach, and you can simply make a decision in terms of what the policy construct needs to be. That's vastly different from what typically you see today, where you do a discovery, you set a set of policies, and then you walk away, and then when changes are happening, you can't react in a much more dynamic way. Oops, Dave, it's not working. The clicker is not working.
The question at this point is, how many distinguished engineers does it take to run a clicker?
That's not worked. So, I did say to you before, we have a policy model as a principal action resource policy model. As you're setting up your set of policies, as an example, you can have your guardrail policies, and then you have a much, much more detailed policy construct that's underneath. So the idea is that you can have your set of guardrail policies to complement the set of discovered policies within the environment. By having this kind of a policy model, where we say principal action resource, if you're thinking about your normal TCP or your 5-tuple connection, it would be source, destination, and then what the protocol stack that you're leveraging, what the effect is that you want to have, and then also what's the condition that's there and what the effect. The effect is an allow or deny, or it could be a copy, it could be something along those lines. So what we've done is actually extend the normal construct for your policy rules so you can have exception handling within your environment. Next slide. So, vulnerabilities. One of the things here is that...
Clicker's working now. No,
okay, thank you. So one of the things that we tend to look at is really, as you have exploits that gets published, how do you quickly react to those exploits? So your attackers are using all the large language models as an example to figure out how they can exploit, take advantage of that particular vulnerability to exploit your own environment. Typically for most customers, it takes a while. So if you think about Log4j as an example, it took a while for you to respond or to make the changes in your environment. So the intent here is that a vulnerability gets published. What we do, we leverage a large language model internally and generate a compensating control, which then could be applied to your particular environment. So we understand the dependency graph, we know where the binaries are, and the compensated control is much, much more surgical. Like in this case, we're saying this run C process is not allowed to be executed in the host namespace. And that's the idea behind that. And we give you much more of a confidence in terms of what's going on. The other piece is that we look for unknown behaviors as an example. So you have known behaviors, but it's also unknown behaviors that could be where you have suspicious activity as an example. You could have, let's say, a web shell execution that's going on where somebody wants to exfiltrate data. We'll be able to see that and be able to block that ahead of time. So with all of that, what we're doing is we're leveraging a set of both generative AI techniques and also machine learning techniques to be able to address these use cases and other use cases that are coming out. So the intent here is really to leverage the innovation, the telemetry from Hypershield, both bringing security from a network infrastructure and an app infrastructure together, making sure we can meld security further into the network and have a much more distributed security architecture. So not only you're getting deep visibility, but you're also getting the ability to apply enforcement, leveraging AI to be able to deliver on the outcomes that matter to you, which is really around segmentation, code upgrades like we were talking about before, as an example, exploit protection. And with that said, we thank you for spending the time with us.